this thing out here. I'm Mike, yeah. And then pop out chat. All right, there we go. All right, and then we'll go over here. Put on this paint. Delete. That's okay. All right, good. Bump, 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 bump. Nobody's talking? What's up, only kind of sorta? How you doing? I'm mad at chat. I'm mad about all the harebrained ideas that I have to field every single stream. I'm a little frustrated at how fractal this project is being, so I'm putting this down in text so that I can put it up on the screen and shut people up so I can actually get some work done. I hate to have to do this, but there we go. It gets very prevalent, and you know, honestly, like I can't get too mad because it's like the thing about the backseating is that people get invested. People get invested in the projects because I am putting everything about the project out. You know, I want people to be invested in the project, and so that drives backseating pretty bad. And then people think that, I don't know, it's like I can't have a personal conversation with every single person in chat. I can't. I just can't do that. I'm not that much of a. I'm not that kind of streamer. I love interacting with you guys though. So you know, don't think it's anything personal, but I need to do these projects and I need to make a little bit of progress here because we've been working on the same stuff over and over again. This thing has been kind of evolving though. It's kind of interesting how it turns into other things that I didn't expect. Like now we have to go into a little bit of circuit theory and learn about current meter op-amp setups. But yeah, there's a balance between working on projects, showing the process, being a goofball, and getting stuff done. And I don't know how to strike that balance. I have not learned that yet. Through all my years doing this stuff. Just dropping in here to be told to go fuck yourself in Minecraft is hilarious. I mean, a lot of people are like, oh, electronics, it's like a trope, right? It's a trope for the electronics streamer to be sort of acerbic, and is that the right word, acerbic? So I'm gonna look that up. I have no shame. Bitter, yeah, acerbic and sort of prickly about what they're doing. I'm here to lurk, so no worries. I don't need y'all to lurk. I love my lurkers. I love you guys, but feel free to chime in. Don't worry about saving face. There's a lot of times where I will like get mad at a chatter and tell them off, and I'm totally in the wrong, but they'll kind of move the goalposts around and tell me that oh, that's not what I meant and stuff like that. So don't worry about that. You're fine. You'll all be fine. There's no need to be scared. Fear not. Disco House Days. Thanks for Space Cowboys. It's my go-to music for working out these days. Also love this song. Don't ask me why I'm awake. That's my what is it? Cousin? That's cool. It's something that I found at Burning Man, and it was just like pop music. It's just pop music mixes. So if you just need something to go on, I enjoy it greatly. And it's not like I don't know. It's me not being a music snob. I have a lot of music snob friends. Everybody's listening to metal now too, so it's like I like something a little bit more upbeat and like, you know, I don't know. It's cool. It's cool that you love it. This is not working right here. This is not what we need to do. Yeah, this is not something that I can do either. Because this would be measuring with two power supplies. Very strange setup. And we don't have this type of power supply. You can accomplish this with this type of power supply, but I can't. I can't do it. So this almost would work for what we're doing. I haven't been listening to a lot of this stuff. I kind of came back to it just for background music. And you can only hear it on Twitch because of the way copyright stuff works. I don't know what DJ streams are doing for that. How are they allowed to use music? How do DJ streams work? I need to talk to a DJ streamer. I don't know a DJ streamer anymore. Metronomic Live kind of went to ground. I think he does IRL stuff. He probably has like a life and he's not terminally on the internet. What's up, Beat Drop guy? All right, let's get rid of all this stuff. We don't need all this stuff. I've made a decision for us. We're not going to get bogged down. We're going to do some circuit testing that will eventually net us a functional tester. Yeah, I need to get back to biking. I need to get back to working out. I don't need to be 700,000 pounds. My body is the shape of a basketball. Like, I really need to. I need to drop a couple pounds. Probably get my headphones out again and get a mix of this stuff going on. I'm not started yet. Everybody's got to ask you that, don't they? They don't understand that there's something called the pre-stream, which is a time that some streamers use in order to allow everybody to gather. Used to be super skinny. You got all the good genes. You got all the good genes. I got the my mother's side genes, and I'm perfectly spherical. I got our grandfather's body, and then some. Both grandfathers were kind of overweight dudes. So I got all the good hair genes, but other than that, I was like, yeah, let's stack the deck on hair. And then I'll get diabetes and be fat. I definitely lucked out. Yeah, he was not as fat as I am, but he was chubby. From what I remember from when he was very old. Used to be fat, then I lost 30 kilograms. Still fat, but not as fat. Yeah, I'm doing a little bit of that. I need to... I think the only way I'm going to do is with exercise. I mean, we got the Corgi, that I love the Corgi to death, but as a female dog, she does not adventure as much. She likes to meander around and see her friends, and that's sort of her life fulfillment in terms of walking. Electric candy router. That thing is modeled off of a gun. I have the drill version of it here. Mahalo sent in both of those, and they're fun little kits, but I don't know how good they would be as actual tools in a shop. I've tried drilling circuit boards with it a couple of times, but I mean this thing trounces it at every turn. Like, just an electric screwdriver like this that has a battery system is so much better. But this thing is cute. It uses a lot of gears, so it makes a lot of noise. It's not as loud as like a hand drill, and it will drill plastic pretty good because it's kind of slow, and I think the drill bit that comes with it is cut for plastic. But way to do it is eating smart. That takes so much discipline, and I love food, so I'd rather work off the calories. And back when I did lose all the weight, I was actually on testosterone. That's really what helped me out, because I was able to build the muscle that would then use the calories. I have a deficiency of testosterone. That is a medical condition that I have. It sucks. Yeah, okay, so as a type 1 diabetic, going to the grocery store is insane because every single food that is like a snack has tons of carbs in it. I can eat meat, but not that much, because if you eat too much meat, even meat has carbs in it. Everything has carbohydrates in it. Everything. It is shocking. If you go through the freezer section, your jaw will hit the floor. Like, it's insane. It's so difficult to do diet stuff. You really have to pay attention. And I've been doing that my whole life, is paying attention to how much carbohydrate is in everything. So yeah, that's the other thing, is cravings, just managing cravings and stuff. I'm very bad at that. Stand up and walk a few steps each hour. And it's kind of what I do. It's kind of what I already do. I'm training the dog to go around the circle. Our neighborhood's like a half-mile circle. So a half-mile circle, if I can do a couple laps of that, even just walking, will be a big improvement over what I'm doing right now. So training the dog to do that is part of it, because she will constantly turn around. She'll take a couple steps in the direction you want to go, turn around and go, oh, we're going this way. Oh, what's this over here? And so getting her to, because she already knows how to walk with you. She knows to heel and to look at you and to be just the right spot for the dog to be in. But she doesn't know when we're going around the circle until I'm 75% through. So, yeah. Yeah, apparently nuts are really good. For dieting. Oh, yeah, for dieting. What's up, milk? Milk. Stay away from the damn sugar replacements. They're worse than actual sugar for cravings. We've been baking with like a 50-50 mix. It's like a 25-75 mix, I think. I forget what the ratio that has been determined. But it's apparently pretty cool. I'm drinking Diet Coke right now. I know, like... Jim Beam and zero Coke drinks. The thing about like mixed drinks, everybody always tells me, oh, you're diabetic, you gotta watch out for mixed drinks. I'm like, no, I gotta watch out for sex on the beach. Like, if I am drinking a rum and Diet Coke, there's not carbs in it. Like, the alcohols, like the basic alcohols don't, unless you're like doing a schnapps or something like that. It's very low in carb. And it's better to have a little bit of carbohydrate when you're drinking, because your liver turns all of its function over to dealing with alcohol, and so it's not going to release glucagon when you go low and rescue your ass from passing out. So there's a whole balance with drinking and diabetes, but it's not like you can't do anything. But like weird mixed drinks are bad, and apparently the sugar eases the onset of alcohol. So you're doing yourself a disservice by buying carbohydrated drink mixes. But overall, like if you're drinking, usually you're using the muscles and moving around or something, hopefully. Like if you go out to the bars or something like that. So you got to watch out and actually, end up eating something at the end of the night just to make sure that you don't spike low. But then with the constant glucose monitor, you can look at all that. All that stuff is happening in front of you in real time. So it's much easier these days. Have sex on the beach all you want. That also uses carbohydrates. Uses a lot of energy. Ooh, poison. I only know the song through Scrubs. Individuals who regularly consume aspartame have the same brain response as somebody who consumes sugar, meaning it can be addictive. Well, that's everything. That's the marijuana is addictive crowd. All right, let's get all this out of here. Getting ready for the day. We're going to be doing circuit stuff. And we're not going to use these power supplies because they fit in the breadboard, but they don't work with the breadboard. Perf board, sorry, wrong term. Bam. Sorry, that boom probably came out of nowhere for the YouTube audience. Individuals who consume... Oh, yeah. Yeah, the point is to get the... Stop smoking weed and nicotine nearly 1 year ago. Damn. Mostly I've gained so much weight and now I have to work it off. Habit changes, yeah. Well, congrats on the quitting. Boom, 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 boom. I'm still waiting for Pennsylvania to go all ham with that stuff and fully legalize it. We should have a long time ago, but... And I guess I could go for a medical. That's what Julian was pushing me. He's like, go for your medical, go for your medical. And I'm like, I don't know. I have I'd probably walk into the doctor's office and they'd be like, yeah, all right, here you go. Just because I have 20 conditions that could get me medical marijuana. Didn't stop since I was 17. Damn, dude. All right, let's see here. These are going to break very quickly, so I don't want to stress these guys out. There's no strain relief on them because they're just testing. Nicotine is an appetite suppressant. Quitting does have that effect. Yeah. And a lot of it is like just time management. You know, hey, I'm bored. That's what it is with me anyway. Right, okay. So we're in good shape here. We are in good shape. Let's do our little diagram here. No, not that. Get out of here. I actually shouldn't. I should do that flat. Hard to do the flat with the mouse. Oh God, that's terrible. No, that's going to be way too confusing. That's essentially how it's supposed to be connected. Sublingual nicotine? Sublingual? Is that a phone correction? That sounds weird. Nicotine's a great drug. It's the methods of delivery that suck. I don't know about it being a great drug. Even without smoking, it's pretty damn bad carcinogen and raises the risk. Yeah, anything that you're burning to put into your lungs, it should be clear that that's really bad for your lungs. Like it's really not good for your lungs to aerosolize something and put it inside of it. There was that inhalable insulin that was like all the rage in the 90s. They were like, inhalable insulin's gonna be a thing. I tested it and they're like, ooh, this is really bad for the lungs. Like it turns out crystallizing something and aerosolizing it and putting it in the lungs is a great way to get to the blood, but it's really bad for the lungs. The lungs are very fragile things. Yeah, it was vape insulin. The protein strands in insulin are huge and they're pretty fragile. To the degree where if you have a bunch of them in a solution in a bottle and you go like this, you can actually get them to smash into each other and coagulate. And so there are stabilizers that they put into the insulin as a formula. And actually, I ran into this with my old insulin pump back in 2014. Back in the, when we were riding dinosaurs back in 2014, I got this pump called the T-Slim. And it was a really cool pump. It was square. It had a rechargeable battery. This is all revolutionary in 2014. Square battery, square pump, everything was like nice, and it looked like a nice little piece of technology. It didn't look like a pager. And so I got this thing, and I'm like, cool, new pump, let's go. And I was on a Fancy Pants super fast-acting insulin. And the Fancy Pants super fast-acting insulin did not have that stabilizer in it. The T-Slim, in order to deliver you insulin, it had a bag of insulin, like a bag, and then it had a draw and inject plunger. So the mechanism inside of it was this Swiss motor that was like really well made, and the whole gearing mechanism and everything. But what it would do is it would pull back a plunger, a little miniature plunger, and then it would inject like 0.7 of a unit of insulin by putting it forward. And all that stuff would come out of the pump and get replaced. So you have the bag of insulin on this little cartridge that would come out. Very clever little system. Problem is, that was kind of hard on the protein strands. And so that would coagulate and cause what's called an occlusion, which is just a blockage of some type of the delivered insulin. So I was getting constant occlusions. I had to use Humalog insulin that had the stabilizer in it that keeps them from, you know, smashing together and producing insulin clots, I suppose. So I went through the ringer with all of this, but yeah, it's a whole thing. So, you know, vaping insulin is not going to happen because heating up those protein strands would just obliterate them. It was very annoying to be like, why can't I use a pump? Why can't I use this pump? What is going on? Why is it constantly failing? And when we figured it out, I was able to get Humalog relatively quickly after that. I had to go like half a day without, I think more than a day without the pump. They've been trying to get a study for treating ADHD with nicotine at work. They haven't gotten it approved. It's not worth the risks. Weird. The known risks. Yeah, well, what's the known risk of basically doing over-the-counter meth? Wait, not over-the-counter. Yeah, over-the-counter. Under the counter is whatever, prescription meth. Because that's the good stuff. That's what makes me a normal person. Otherwise, I sit and I click the computer all fucking day. It's happened before where I've taken like a tolerance break for a weekend and I'm like, I've been on Reddit for 25 hours. Like, what am I doing? Why can't I get up off my chair? I have too much to do. Tiny doses of nicotine in pill form. Weird. Oh, this song. I remember this song. This is from way back in the day. We are so far into the yak right now. I think we've shaved through the yak. There's no longer a yak. It's just like 4 hooves on the ground. And we're sitting here peeling off single layers of cells at a time. Because in order to run basement jacks, that's right. I used to listen to this in high school. These current meters are low side current meters because that's what's cheap. And because that's what's cheap, that's all that's available, which is very frustrating. And I don't want to go all the way out and do, all right, Disco House Days, you have fun, man. Thanks for dropping in. I really appreciate talking to you here. It's weird talking to you here though, because it's like public. So I can't be candid. What progress did we get to? I can't get both of these things working at once, and it's because of the way they are. They are low side monitors, and because the power supply is going to be the way that it is, we tried to use 2 power supplies in order to isolate out the ground in the same way that YouTube video did. Here, we tried to do this essentially. Let's get rid of this and do this so we can see what it is. But I tried to do this, but because my power supply isn't split up, it's just one thing that produces plus minus ground. I can't do this. We don't talk anywhere else. I know I'm exceptionally bad at contacting family because I don't go on Facebook anymore. I don't touch it. Yeah, the Zoom birthday streams. I know, man. I know. I am perfectly contactable, I guess, if you have Discord. I loathe Facebook, so it's hard to get in touch with any of the family. So our parents are boomers, and as such, all the boomers all had a bunch of kids, and so we've got a lot of family, a lot of family to stay in contact with. Just makes me want to keep working on my SID synth that I started 10 to 15 years ago. Hell yeah, Jacozy. The stuff that we've learned about synth design and analog, oh my God, my eyes. And analog electronics and stuff along the way have really bolstered my confidence in working on musical stuff and just analog stuff in general. I mean, synthesizers are a wonderful sort of stepping off point because there's a set goal and you can buy any level of kit to match your electronics mastery. Just join the Discord. Cool, man. Yeah. I'm usually on there. So you have a minus 12 volt source, it gets fucky. No, actually, the minus 12 volt, this is why the whole thing was thrown on its head. Because originally I thought, oh, plus 5 and plus 12 will be easy for me to do current monitoring on. It's that minus 12 that's going to be tough to do. Because how do you measure? But it turns out all of the current monitors online, because people are doing like, they're doing like, you know, like e-vehicles. They're doing like electronic motor stuff, right? And so you want to monitor your big battery bank that's at 300 volts, and this thing only monitors, or like it can go up to 100 volts actually. So this one goes up to 100. So you're like, this battery bank is 100 volts out of my 300. How do I monitor it? And it's like, well, how do you make those electronics cheap if it's at 300 volts? So the way you do it is you do a low side current monitor. And so you're on the negative stuff and the voltage is low, and so you can take that into your low voltage microcontroller without blowing it up. But the problem with that is that now everything cheap is a low side monitor, and in synthesizers on our 12 volt low voltage stuff, we can't do that. We can't do that because everything's sharing a ground, because that's logical. So we're forced to do some fuckery with op amps in order to create a current mirror that we can have monitoring the high side. It's ass. The whole thing is ass. But getting the right resistors is going to be part of the day. So it's annoying. Oh my god, Doug's howling. Been getting super old suggestions on YouTube all day, so I've been listening to Sid Metal. I don't know what Sid Metal is. And now you're working on some modular stuff. You want to keep working on the Sid synth. I don't know what that is. Yep, everything is copied and yep. And so everything is this like very simple microcontroller with a low side monitor. So these things would be very useful if our topography was a little different. But unfortunately, we have positive, ground, and negative from one power supply, not two. So we can't replicate this circuit without the high side monitor monitoring all of the current coming back from the negative rail. Unless I'm misunderstanding something, and I might be. The synthesizer is based on the SID chip, which was responsible for audio in the C64. Oh, that's cool. I don't know about that chip. I don't know much about this stuff. Oh, there were a lot of drums. Yeah, we need to get back to the building of the rest of this thing too. I think what I'm going to do is I'm going to do op amps in through-hole op amps, but put them in sockets in case I blow anything up. So just use sockets, use the breadboard, try to spread out as much as possible. It would be better if this thing could be a circuit board that's like this big, and I could really spread out all the designs. Yeah, that's the one for most chiptunes. For the C64 slaps so hard. That thing makes some amazing chiptunes. We did a little stint where our intro music was tracker music for a little while. People got real good at that. Made some good sounds. See, our tester has taken on a completely different sort of design than this one. This one is very functional, and it probably would get me everything I need. It's just we have the capability of doing more, and so we've ended up doing more. I have the capability to do 8 channels of audio coming out of this thing, and so we opted for 6. And then using muxes, I am able to switch things around so that any of the outputs or any of the plugs on the front can become ins or outs, and we can monitor 2 channels, and we can output on all the rest of them with individual waves. We've got such a powerful microcontroller that it's not even going to break a sweat doing that. In addition to that, we're going to be capable of displaying a little bit more detail on what's coming in the signals. That's going to be a coding nightmare, but it will allow me to have something like an oscilloscope view, which I understand better. Maybe not at first, but we'll at least be able to measure tone and frequency and stuff like that coming in. and that'll help it do its thing. So in addition to that capability, we need to be able to make this instrumentation level accurate. And in order to do that, that means calibration. Calibration is very important. I have voltage source, reference voltage hardware, and it came from all the mutable instruments stuff, because the mutable instruments devices are amazing. So what I have is a positive and negative 10 source on the same mux that's switching signals about the input jacks. And so I will be able to put a negative 10 or positive 10 source on the line and hear it back through all the hardware, sense it, and output another, like a 10-volt signal and compare. I can compare things. So we can have an auto-calibration happen on this thing. So, as much as I pan the Rigol DH914 for its 1 minute startup time, it takes a minute, 1 entire minute. That's a whole cup of coffee to start this thing up. Our own device might take a minute to start up because it's going to have to go through and do all the self-testing. What is the music doing right now? Oh, it's just being crazy. Ow, every time I pick this up, I'm putting my fingers into through hole. Let me clear the field here a little bit. I see what the efforts that I've been doing are to get hardware squared away. Once we get all the hardware down on this thing, we can then sit at our computer and plug away at some type of a UI. And that UI, we can use something like LVGL in order to help us sort of put that all together. So I want this to be just this sitting on the desk, because eventually I'm going to get so mad at the programming that I'll want to just do something else. I'll do like a physical project, work on Burn the Subs, that kind of thing, and then this will just be a self-contained project box. So in order to get there, I want those current monitors on the power supply. I want the power supply to be squared away and ready to go, because the rest of the circuit is fairly complicated and it's a lot of stuff. And I want to make sure that it's all spread out so that I can easily go in there and fix things when I need to. Sid Metal's a weird combination, why was that hard to say, of metal and chipmunks. Huh. I can toss a song or two on Discord for later. Yeah, I want to hear those chipmunks. I know it says chip music. What's up, Scoot Shablam? We're getting well into the weeds today. We are going to be yak shaving like none other. Oh, hey, that actually works. I don't know if it's kosher to be putting the adjustment wheel on stuff, but that's actually kind of funny. That holds it perfectly. 1 caliper mount. I was looking at flashlights today. People be crazy about flashlights. I carry with me at all times my poop finder. This is a flashlight that has a very good beam. I looked up on Reddit and I looked up, flashlight people. I looked at what flashlight people were saying about their flashlights. Because, that ProZD skit about yes, drinking water. This one has a nice crisp flavor. That skit is absolutely true. That is 100% truth. There's no comedy in it at all. But I looked up the flashlight people, and people are serious about their flashlights. They're crazy. And so this one was actually recommended pretty well. It's just a little Coast pen light. It has an adjustable lens on it and a very even beam. It doesn't have a lot of noise on the beam. And it's rechargeable with USB-C, but you have to do this. You have to unscrew the thing in order to recharge it. I keep the silicon bite thing on it because I bite it quite a bit, actually. USB-C right there. I use this thing all the time. This sits in my pocket, so if I need to inspect something, I guess it's called an inspection light, if I need to inspect something, it can either blow out my retina through the back of my head, or I can double tap and it'll go to soft mode, which I've used on stream before to look at the bottom of screw holes on the cameras. This thing helps me find poop. And actually in the future, we do have a project that I want to do. My brother gave me this almost useless thermal imager that uses a very cheap thermal imaging core. Little thermal imager with a screen. I want to make a brown case for this and have pictures of dogs pooping on the front, because this is going to be the Poop Finder 3000. And we might do a laser line driver on both vertical and horizontal, so it makes an X, so that I can find the heat signature of the poop and know where the poop is. This is going to be the Poop Finder 3000. We need to add a battery to it, too. I don't have a battery that's the right size. Very enthusiastic reviewers. Yeah, flashlight people are crazy. They're crazy. Is chat is that showing up on screen chat? It should be. Rescue Rangers, a couple metal. Did they actually had a couple? Make sure you don't misspell flashlight on Reddit. Oh, Jesus Christ. It was. It's not right now. Huh. I need to, okay, so where's that? That's, chat overlay, properties, and then I'm going to hit refresh on it. There we go. That should come up. Yeah, I didn't know people were chatting when I was, proselytizing, whatever. Poop Finder 3000 sounds like an interesting product. We need to explore its capabilities. I don't know how much. It's probably like $70 for that thermal core, and it's almost totally useless because it's not very good at showing thermals. Like the Lepton core is $150, the one that's in this thing, and that can show you a picture. You can actually see detail, whereas the other one, it needs like an overlay to really see what's going on. It's not a very good thermal imager. But if we're finding poop and I'm keeping this thing in my pocket, like during the winter, that's fine. That's totally fine. I think that would be hilarious to have. And I don't know if I could market it to pet owners. You might as well just get one of those Fluke, like little gun style thermal imagers. Those are cool. I was gonna get one of those, but this is what I do with thermals. Some red lighting gel in my best flashlight in order to use it when needing lights in the sleeping areas at events. Ah, that is a good one to do. So a lot of these pocket flashlights that I was looking at now, they're starting to make the designs square because you're keeping it in a pocket. V. Newcomb! I use a walking stick to point to the poop. Well, that's a good idea. I mean, we have like some tall grass here, and when the dog goes into the tall grass to find Pokemon, it poops, and then I can't find the poop. I've had a couple instances of that, and it would be so much easier just... This is that annoying segment of house that I really don't like, where they just repeat stuff over and over again. Oh, I can't fast forward these days. Damn it. I'm just going to turn it down. It's just like this kind of house where you get a beat in the background, and then the DJ just starts throwing stuff in. So they'll throw in, and or maybe the music producer throws stuff in, and so you get, and then beep, 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 just for like the whole song. It drives me nuts. It drives me crazy. But I was saying, well, like with the Poop Finder and with flashlights, that's where I was. With the flashlights, a lot of these flashlights, they're starting to build like these, you know, we can create a flashlight that'll burn your socks off, or literally burn a hole in your pocket, both with cost and with the power of the LED on it. They're super powerful now, right? These LEDs can just bust out your retina any day of the week. You basically have a portable sun in your pocket. But what they've been doing is trying to make them more functional and small, and you've got like this pen light style flashlight that can view anything within a mile, but now they're including like green laser pointers and a UV light. And it's like, what are you going to do with that UV light? We were talking about this in the Discord, and it's like, what do I do? Why do I need a pocket UV light that's on me at all times? I don't need that functionality. I don't even need a laser pointer because I'm not giving presentations. These are executive toys at this point. The UV, I guess, could just show you how filthy your office is. And as executive toys, because the price point is pretty high, why does an executive need UV? They're not using paper money for anything. You know, they're buying cocaine with a credit card. I'm not doing anything with this UV light. Maybe just to check the quality of the cocaine. Why do I need to carry around ultraviolet light? And then in addition to that, there was a picture that I saw of somebody with a hole burnt in their pocket because they put this thing in their back pocket and sat down in the car, and it activated the flashlight, and the flashlight was that hot and bright. Crazy. All I'm looking for a flashlight, I need something that my dad can use. Because when my dad takes the walk at night, he uses a flashlight, and he uses the flashlight until the battery is just begging for like the sweet release of death. I would like something that he can drop into a charger. And so I was looking for flashlights that have charging docks, and most of them are like the Warrior's mag light that you put into the charging dock, and it magnetically recharges, and that's not what I want. We've got a fancy foyer in the front hall, and I want something that looks fancy enough and is easy enough that you just drop the flashlight into it. And I don't see it. I don't see it, and I don't really know why. So my thought is, what I can do, find a flashlight that has a charging port that's at some kind of an interesting angle where I can have something that the flashlight drops into, and then I have one of those magnetic adapters for like the break-off charger. That's all I can really come up with. There was a product that I was looking at that had that. Oh, that's right. No, I wasn't looking at it. I saw InRange TV reviewed. HoloSun is like a manufacturer of weapon sights. They make really good ones. They're very nice, and they can survive rough, conditions and all that stuff, and they're pretty cheap, and they work really well. What they've done is they've made a co-witnessing camera and red dot that can work in very low light, which is really, really cool, because then you can run around in low light. You don't have all the night vision gear on your head, and you don't have to like get your night vision goggle close to where it can see through the sight. You just look through the sight, and you look through the camera view, and it gives you kind of hazy outlines of stuff in the dark. And then if you have an infrared illuminator, you see like it's day. But the way that you would get footage off of that camera, because the camera, you've got a camera on the thing now, let's record as well. If you want to get that recording off of it, you have to connect USB. In order to connect USB, what they have on the outside is just one of those magnetic adapters. And it looks like the more universal one. It looks like you could just buy any old magnetic adapter and this would fit onto it. But InRange TV was criticizing it based on, the magnet's not very strong, it pops off very easily. And it's like, well, that's not what it's for. It's there to charge your device, and then it's there, if you really want to take that out with a USB plugged into it, put a piece of tape over it. But it's cool that they've done that, because what that allows them to do is seal their device from the environment and have a couple little pins with a magnet around it facing the outside. That'll pick up iron from the dirt, but still. All right, where's chat? Chat fell to the back side. Wonder what voltage you could get from that coil. Oh yeah, they included on the toothbrush. Philips has done some great stuff. Sonicare, the toothbrush that I use, they have, it's a glass. It's a drinking glass that you put your toothbrush in and it charges. So if you need a drinking glass to like wash your filthy fucking teeth, you can use that as a glass for water, and then you drop your toothbrush in it with the charging stand, and it charges your toothbrush. So it looks very smart. It just looks like you have just like a normal toothbrush sitting there, but it's actually charging. Very cool. Yeah, I wonder if I could use something like that. There are add-on inductive charging pads that you can put on like your phone for older phones. I wonder, but the problem is that all these flashlights, they're all metal. Some of them are aluminum though. And there's actually one flashlight that has a plastic body, and it has a hybrid power system. You can put a AA battery in it and use that or the charge. I like that one because it's square, and I could put that little magnetic charger on the side of it. But I wonder if you could somehow, if you could get into it. The problem is all of these are sealed from the environment. So a lot of these, you won't be able to get in and like doctor stuff the way we like to do. But if I was able to get into it, I wonder if I could access those USB pins and put a coil charging pad inside of the plastic, and then it would be something that you could just drop onto, like a 3D printed stand with a toothbrush charger in it. That would be very cool. You have a little QI coils, roll it up and shove it in. I'm not sure if that would work rolled up, because really you want it flat to make as much contact area as possible. Yeah, but I'm thinking about it. Good God, I need a light, not a toaster. Yeah, exactly. Is there a flashlight mod for regular drill holder? That's an idea. Oh, Veet Nukem, by the way, 31 months. Thank you so much for those primes. Yeah, it doesn't need quick charge. But from what I was seeing, I think my best bet is, and the problem is the only one that fits this criteria for me on all the right points is the one that has the extra AA battery, and I don't want that. I don't want any more like fixed batteries in the flashlight system because it's a huge waste of money. And I know that my father will stop using the thing, and then he'll start putting batteries in it. So maybe I just can't help it. Also, the buttons look hard to get, and he has arthritis, so I don't really want to. I want like big, easy to push buttons on the flashlight. The ease of just dropping it onto a charger, because the square ones you can build just like a little thing, and it'll just drop down, and then the magnet makes contact. Right? No need for coils wasting power. If you could get it to work at all with a coil rolled up in the battery compartment, that would also be fine. Yeah, because it doesn't need quick charging for sure. Because it'll get a little bit of energy every night because it's just an LED. Yeah, I gotta work this one out because I bought my dad one of these and he's too lazy to bring it downstairs. So I could put a USB-C charger in the front hallway. He still wouldn't use it because he hasn't brought the freaking flashlight downstairs. But this one, unfortunately, I would absolutely do that with this one, but you have to like open it up in order to get to the charging thing. So wrap it in tape and have the coil charger on it. All right, let's get started. We got some work to do here. So by way of explanation, I'm going to put this up for a bit. And then we need to get some stuff. We need to get some circuits and figure out some equations here. In order to test Eurorack stuff that is broken, I need to see current draw at any time. Big current equals fried parts. The modules take 3 power rails, +5, rarely, +12, and -12. They all share a ground connection. That should be underlined. Cheap current monitors use low side designs to avoid higher voltages. I have 3 cheap monitors. We can't really find a high side monitor. That's tough. That's tough to search and it's tough to find. Maybe like DigiKey, or if I go to SparkFun, maybe I could find something like that. But they seem to be pretty rare because of the expense, I guess. When you talk about just purely shunt drivers, like shunt amplifiers, those are pretty prevalent. Those are all over the place. But that would mean that you need some kind of an analog read on the end, and I don't want to involve more microcontrollers. So I have 3 cheap monitors. Low side works for -12, and that's the circuit that I'm showing down below. But the others would be measuring everyone's current through the shared ground. Because it shares ground, circuits work in loops, we can't isolate out the positive voltage from ground. This would also affect the 5-volt one too, because the 5-volt doesn't have its own isolated ground. So when we looked at this circuit yesterday, it seemed very hopeful. This one seemed very hopeful. It seemed like the right scheme. But the difference is we don't have the power supply separated like this. In my main Eurorack module, I could do this because I do have 3 power supplies. I've got a positive, -12, and 5 volts. 3 different things. Now, while we could do that with this, I want this device to just not be that annoying to use. I have 250 milliamps of 12 volts. Hopefully when we turn that into 5, it'll be enough to run the VFD. I will be very pissed off if this is not enough to run the VFD. How much 5 volts does that thing use? It was like 500 milliamps or something. I might have to edit the title. We might be able to use this scheme because I might not be able to build using these devices. I'm not going to parallel these two. I wanted them to be 2 separate power supplies, but, big but, 250 milliamps versus, all right, where's my data sheet on this thing? There it is, GUI, whatever. GUI 14032. The 280 is actually a more accurate data sheet, but this is the size of the screen. The 140 by 32 is the thing we're using. There's one that's like super long and it's got way more horizontal pixels. That would use a whole lot more power. So power supply, 5 volts only, serial interface, blah, 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 blah. Blah, blah, blah. VCC, 0.3 to 6. Minimum is -0.3. I guess above that and you damage it or something. Logic input, okay. Electrical ratings. Power supply voltage, typical is 5. Parameter, logic level, power supply. Optical specifications, environmental specifications. How many milliamps are you using, bud? There were 2 ratings for that. One was with all the characters activated and one without. I remember that now. I need to find it. Maybe it's up above. It's not. It is not. August 4th, 2023, huh? Wait, really? Maybe they re-released it or something. 2.5 watt, maybe you did, yeah. Well, let's find a more on the nose specification here. We're looking to see if even what I'm talking about doing today is going to be viable. Because if these little power supplies, okay, so Bother, what are you doing right now? Why did you pause and go in a completely different direction suddenly? This happens a lot, actually. Oh, here's power supply current, 500 milliamps DC. Here's what happened. Stream intro and everything looked like it was going swimmingly. I was under the impression that these CUI incorporated power supplies would be adequate to power everything in the circuit. I went out on my way to buy these things because they are so simple. It just takes DC in one end and it poops out modular synthesizer rack power. So I figured I'd use two of them, one to do whatever's under the scalpel, and then the other one would be our own supply that we would use to power our device. I have a different way of making Eurorack power supply. I have 3 modules that all do the individual voltages, right? And so I thought, okay, so we're just going to use these things. In order to do that, we have low side current monitors, so we'll have to do some pokery with op amps to make what's called a current mirror circuit. And I am unfamiliar with current mirrors. There's one in the diode ladder filter actually uses one of a current mirror style circuit to turn voltage into current. See, with a current mirror, we're turning voltage into current, or current into voltage, and then back into current. And we can then have a low side current that we monitor that's mirroring a high side current. See what I'm saying? That like simplifies things and makes it so that this is possible. And it's yak shading. This is getting fractal. This is what I'm talking about. The more we zoom in on something that we want, the complication comes back, and it's the same problems that we're dealing with all over again, just the different flavor. So if these little modules that I bought, and it's possible that I could buy higher current modules, but I'm not buying more stuff. These little guys that I bought might not have enough current to run our screen, in which case I need to then change gears with the power supply and use 3 individual modules. Well, that means that I have 3 isolated grounds that I could monitor individually in order to get how much current is going to our, to our thingy-wingy. So that would mean that this is totally possible, that we could monitor all 3 of the currents of 3 separate modules using 3 separate grounds. I think. I think. So under the big table, this view always shocks me when I accidentally click on it. Under the big tables, we have power supply current 1, 2, and 3, power consumption 2.5 watts, 500 milliamps, 400 milliamps, and 30 milliamps. At 12 volts, what does that mean? 2.5 watts at 5 volts. This is dimensional analysis, isn't it? Oh God, I hate doing this stuff on, so V is equal to IR. So V over I is equal to V over I. And what is it? Watts are VA equals W. So VA is equal to VA. So 12, or no, it's, hold on a second. No. Oh, those are supposed to be I's. God damn it. V times I is equal to W. 5 volts at 0.5 amp is 2.5 watts, which is the total amount of power. But what is it? There's a conversion here. So when I convert it, I get more amps. So hold on, let me just fix. I fucking hate math. VI is equal to W, right? So VI is equal to VI. So 12, or no, 5 and 2.5 watts. So V over W equals V over W. So 2.5, so 12 over 2.5. No, 5 over 2.5, sorry. 5 over 2.5. I haven't had enough coffee for this. 5 over 2.5 equals 12 over X. So 5 over 2.5 times 12, right? Because we divide, or no, 5 over 2.5 divided by, yeah, watts is equal to V times A. Or I if you're doing the proper current nomenclature. 5x is equal to 2.5 times 12. That's very clearly a 5. I don't know what you're talking about. Calculator, help me. .5, 12, 30 divided by 5. That is not 6 watts. That doesn't make any sense. What did I do? I fucked it up. Anyway, whatever. I hate math. I hate math so much. Screw all this. If anybody else wants to calculate that, I would love to know. But the point is, 2.5 watts is like half an amp, and we have 250 milliamps for plus minus 12. So I don't think it's going to work out. I don't think this is going to be enough current. This is enough to power a module. The problem is, the alternative to this is that we juice up the power supply to the point where it's so roid ragey that we could reduce modules to dust. We would turn them into ash in one single arc welding event. That sounds more evil than it should. Time for a twisted transistor. You think it's 200 milliamps at 12 volts? Well, that's using up our whole power supply, and then we would have 50 milliamps to power the rest of all of the op amps and everything. And we know that that uses a bit of current because we've had that circuit running with all 6. So I don't think that's going to work. Yeah, no, this could handle, if we had a much more, you know, if we didn't have such a take a big steppy style screen, this thing could probably handle the whole module. But since this is a testing module, we're going to need more current than that. So everything that I said today was a lie. We're not doing current following circuits because we can't power the screen with what we have. Damn it. I mean, USB power isn't enough to power the screen, so that should tell you. I chose it because these are good for an individual module. Like if I were to build like one of the Hajuo designs and I wanted to just throw the power supply in there, like I thought that this would be good for a little tiny test stand. And the test stand took on a little bit of a new direction, and I wanted to use a very fancy display. If this is a regular LCD, I don't think we would be having this discussion. But since this is not a regular LCD, the incapability of these two CUI products has actually saved this project, and we were able to do a much more simple wiring scheme. Back to my title. This project is fractal. Power supply design time. There we go. Done. USB 2.0 power limit is 500 milliamps, so it's at the limit of the screen. I wonder if they planned it that way. Okay, so new problem. We got to work on our feet. I'm gonna have to start making my titles for streams more nebulous and universal. I'm gonna have to have like tomato style conversational titles to my streams. Because, okay, here's new power supply. New PSU. scheme. And we'll test this. We got to make sure that we test this before building it. I don't want to leave this stuff untested. So we've got a module, and a module. And we have all of these wired together to 2 rails. We'll go out here. These are always annoying to draw. Like this, and like this. And this is going to be 15 volts. AC. Might be able to make that AC, but you know, whatever. Yeah, if I use USB 3 or if I use negotiation, but 5 volts, 2.5, and 12 volt, 0.2 out. Suggestion: person does something with electronics to avoid negativity. So we have plus 12. We have, well, actually, plus 5, plus 12. What was the wiring scheme for the minus 12? I'm gonna have to look that up again. I think there was something in particular about that minus 12 and the way that it's supposed to be driven. So let me look that up before I get too far into drawing this. eBay. Negative 12 volt. Damn it. Negative 12 volt. Yeah, power supply, I suppose. It's more of a DC to DC converter. Negative 12. Oh, and they got rid of the minus. So we're going to quote negative 12 volt converter. Electronics on eBay is pretty difficult to search. Maybe module. PCB would be the next one, but there it is. I think that's the one. So in this case, we have V in and ground is shared, and then it just outputs. But what about the negative 12? This one doesn't do negative 12? This is not the right one. This is not the right one. Not the right one. Okay. I gotta find the same one that I've already bought. Is this not searching for negative 12? Should be. Push comes to shove, I could look inside the synthesizer for the one that I already built. Because that one works. You know, most of the time they're hanging the power supply off of ground, just using it as, like, you know, ground reference kind of stuff. But in this case, this is specifically a 12 volt, a negative 12 volt power supply. Computer power supplies have negative 12 on it from this bygone era. Where are the PCBs? Nope, 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 nope. Well, step 2 is going to be finding the module, too. I'll have to find the module. Maybe that'll give us a little bit more information, and I'll be able to search up something if there are markings on it. But we're basically just doing this 3 times. Is there a reason you couldn't just use a 12-volt power supply with reversed polarity? No, it's just, you know, I don't want to. Yeah, I don't want to be using them at 80% utilization. The problem is these power supplies have, like, the ability to reduce a module to dust in terms of the amount of current that they can let through. So I didn't want to use these modules. I wanted to use them in a power supply for my other modular synthesizer. The only other question is, what did I do with them? Sanya power. What is this one? That looks very familiar to the other one. +5, -5? What was this thing? Why do I have this? I'm gonna put this over here. I don't know what that thing is. It's a weird thing. Weird circuit board. I believe some of the power stuff ended up in this pile over here with the synthesizer things. I shall need to investigate for further information. Send a search party. I don't see no power supplies here. Maybe I reabsorbed them into the lab. That might have been the way that I went. I was going to take one of the distribution rails from the suitcase that I put together and then use that in the second one, because I don't need that many power hookups. You do need them, but you don't need 2 distribution rails in that size of equipment. Oh man, I got to stretch my legs more. Woo. Okay, legs are stretched. Let's take a look and find some of these power supplies that I used previously. All things considered, I thought they were out. Oh, my buttons came too. I wonder if I should replace the buttons in there, because I think these are 14 millimeter and these are 13, and you need 10, and so just a little tiny bit will be sticking out. It's nice to have more button than this. These aren't really sticking out. The other thing that I could do is put a plastic cap on the top of the tactile buttons and open up these holes a little bit. That means more printing, but then I would have like a big button that you could press, and it would make that clicky noise. But for now, this will do. This will be just fine. Okay, power. Maybe you could go from a diode rectifier to a 25 volt AC. Maybe you could do this. Maybe you could do that. What if you did this? How about you do this? Bother, do that. Do this thing. Do this other thing that I suggested. Hey, why don't you do it the hard way? Why don't you do it this easy way that's actually disguised as the hard way? Why don't you do it this hard way that's disguised as an easy way? And that way you can get more frustrated. Listen to me, listen to me, listen to me. I'm not building a power supply from scratch, for fuck's sake. This isn't Electronics 101 where I have to plug a transformer into the wall in order to make my power. I have all of the components for a pretty beastly modular synthesizer power supply. This is the negative 12 volt source. And this thing has some brutal specs. It's not as crazy as like the power supply, the $600 power supply we looked at the other day, but anyway, this is the negative 12, and we have A07 version 9. So maybe we'll look up A07 V9 negative 12 volt power supply. A07 V9.0 negative 12 power supply. Nothing. Oh, look, there it is. Bada bing. Oh, Google Images actually came out on top. Game mini joysticks, nice. Parameter, input voltage, 5 to 36 volts DC, and it outputs negative 12. It just does the work for you. Picture show. No circuits, view more. No, there's not that much more. Please be a circuit, please be a circuit. Son of a bitch! I just want to know how to hook this thing up. This thing has a giant shared ground. So we're going to have to isolate the module itself. Actually, what we're going to do is isolate the negative voltage into this thing. So that should be fine. What if you used a potato to step up power converter? That's right, I need to go get more potatoes, and I'll put the potatoes together, and then I'll grow some silicone, and I can produce a MOSFET. Anybody have metal oxide on them? Okay, so this will do the negative 12, and I suppose it just sits between positive and negative voltage. So that gets V plus and ground, and it makes V0 minus and ground. So this will just be V0 minus. And then we have ground and VN. but then V0 minus is going to go to the meter. And then go to -12. And then ground, which is actually connected there, ground is going to go to normal ground. But we can get +5 in ground from the +5 volt thing. Here, let me just cut and paste this before I forget. The thing is, like, these power supplies can be fed off of their own supply. They should get an isolated supply because that means that they are capable of running at higher voltages is really the advantage of that. But we measure the individual ones, and then we send this to +5. And then this goes to this same ground. But we're measuring the return to that module through our stuff. So it's weird. But this should work, right? Because we're individually. I shouldn't draw it like that. Hold on. +5, and then this one's +12. And then we measure the individual returns to these modules. From our stuff. So this stuff is like satisfactory. This stuff is, while it's the internal stuff is not measured. How does that work? And then the V-sense is going to have to go to ground for this one. V-sense should go to +12 on this one. Or should that one also go to ground and then it's not measuring it? No, wait, what is that one doing? What happens over here? Keeping all the pluses and minuses in check is kind of difficult. This one is using the yellow wire to go to the positive rail. Okay, yeah, and then that one goes to ground because that's above negative. Okay, yeah, so that's just the way it works. So +5, and then this one goes to +5. And that'll just monitor itself. Okay. And that's the total internal voltage, though. So that's not really going to... Maybe Circuit Lab will help you plan this? No, we don't need Circuit Lab. I just need to scratch my balls for a little bit and figure out exactly what's going on. And I think this is the scheme. We're going to test this, of course. We can't leave things untested. But this goes, so internal. So this is just +12 and ground. Oh, that's a really good looking G. -12. So what that means is that power returning through -12 goes through here, and we get a current there. Power returning to +12 goes through here, and we get an isolated +12. And then power returning to +5 goes through here, and we get an isolated +5. This is possible because we have 3 separate modules. And then we have a a voltage sense pin that just goes to whatever the positive rail is. In this case, the positive rail is G, but that'll still give us a measurement against its lower potential, which is this. So the black wire on all of these goes to it's just all the black wires go to the same thing. So that's yellow, red, and black are the 3 wires that come out of these. And that will give us 3 separately powered displays off of the 5 volts. So it'll I think, isolate and use just 5 volts. And if it uses 5 volts, that means that our voltage readings can go up to 100 volts. Wow, that'll be so useful. Yeah. Yeah, look, I know there's all kinds of really wonderful tools out there, but this is funny. So we do this. And I know I can get all kinds of circuit simulation and stuff, but listen, in college, 1,000 years ago, we were riding dinosaurs back then. In college, we had, oh God, what was it called? Whatever that simulation software is for circuits. And it was like a programmer's practical joke against electrical engineers. It was the worst program ever. It was so horrible to use. You would build up like the simplest simulation, and you would hit simulate, and it would throw up an error and say, spice, yeah, not P-Spice, but just like the original. You would throw up all your parts, and all your parts would go on the page, and then you would hit simulate, which is fairly straightforward. Simulate, I click the thing, and you simulate the circuit, right? And you give me numbers. Because it's a resistor. Just tell me what the resistor's doing. Why can't I know what the resistor's doing? And it goes bap, and it gives you this error, and you're like, why? I'll double check everything and make sure my parameters are right. Do I need to know exactly what kind of resistor is? No, it doesn't need to know this information. Maybe if I give it this little detail or that little detail, and I give it all those little details, and everything is together, and I've fully told the simulation all the information that it needs to know, and then some. It knows like my shoe size. Why do you need my shoe size? And then you hit simulate and it throws up an error again. You go, oh, fuck, what have I done? Why? And you hit it again and it works. You didn't do anything. I didn't do anything. I didn't change. Nothing changed. I just hit the button again. But now it works. And so I hate simulating circuits. I hate it. 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 We have all of the stuff we need right here to make the circuits. I don't need no sales pitch about something I need to be using. We need to find 5 volts, so we need to find 12 volts. I don't know. I didn't label a lot of these power supplies properly. I really should have labeled them as soon as they got into the shop. Oh, he dead. This one dead. There's a big hole in the chip. That's right. This is a dead one. I even labeled this, so I marked it. I said 12. Or no, 5. That's a 5. This thing died a warrior's death. All right, so let's find another 5-volt one. And then what is this one? This one is likely 12. This might have been a $20 purchase right here. I think it was. And this is a 12-volt regulator. These are complicated. Pololo makes a mean regulator. They make a really good regulator. This thing can do amps. I don't think we need multiple amps of 12 volts, but I guess we'll use this one anyway. It's what's in my regular synthesizer build. If I can find a smaller 12-volt source, I'll probably end up using that. All of my regulators are in this bin up here. Probably one of the more pricey bins that I actually have. So here's a 5-volt regulator. We will use this one. We'll have multiple amps at 5 volts. Labeled 5, as to not confuse anyone. Engage your brain, Pololo. These are good. These use some pretty decent power electronics to produce a lot of current, and they're just in your almost standard 7805 style. Is this in ground out? I think that's swappable for a 7805. More efficient too. So here we have our negative, positive, and 5. So let's get some pins on these things and get them onto the breadboard. And I guess I'll do them at a right angle so they stick upwards. This one has to be horizontal. Maybe we'll do, no, you know what, we'll do horizontal with all of them. It would be nice to be able to see all what the pin designations are. Is there a status light on this one? No. So if I put a pin header on this side, I think it gets in the way of the coil though. Yeah, so I might have to do it on the other side. All right, let's get some pins out. You go away. It was something like a $40 to $50 power supply, but it provides very clean and a whole buttload of very clean power at that. Sorry, I had to burp in the middle of that, and then I took it in a different direction. And then I burped during that. Whew, okay. And we'll make a harness for we'll make one of these for this one. Whoa. Oh, that's the labels on the front. Wait, which side is V and which side's A? Uh-oh. I don't know. We'll copy one of the others when we get down to it. All right. Let us get started. Oh boy, not a lot of people today, huh? Everybody busy. All right, get this to the side, and let's start building on here, and then we'll bring the screens back in and hook them up properly, and that'll hopefully be it. I guess I'll do input and output here and not do rail to rail. We were going to be using op amps today, but it turns out we don't have to. I can get this running now that we're using individual power supplies. Oops, I just messed that up. So with 3 individual power supplies, we're able to isolate things properly. I'm reminded of the story of PC Store Boss, where I built PCs, got his master in physics, went to MATLAB, showed a friend, finally figured out how to program this complex geometric figure in MATLAB. Oh yeah, MM files. 3 days of work, and his buddy said, "Oh, you just click this," and there it was. Oh man, we had to simulate a lunar rover and do like the gas estimation on it, which is essentially just making a game. And I definitely copied that homework, so I don't know a thing about programming MATLAB, but you can do a lot of stuff. MATLAB is insane. You can do anything with it, but it's so funny that there's just a button to do complicated shapes. That's pretty good. All right, so let's get rolling with this. I guess I'm not using these two. When am I going to use them? I thought I was going to build a little tester module, but nope. Maybe I can make just like a little cage for like a single rack unit thing. Oh well, those are a good idea, but they caused a lot of complication. Pins. I need pins. Where's my pin at? There they are. Sorry, I gotta reach under the light in order to get them. This is the kind of contortioning that I do around here because my lab is a mess. All right, we're using straight headers because these things are going onto a circuit board eventually. They're going to be here, and I don't want them to be too tall. They would be too tall and unwieldy. So do I use circular pins? Are those going to clash with this? I guess that works. Circular pins, they hold on better. These circular pins hold on better, and they're lower profile than the normal headers. So I guess I'll use these. The only problem is when you use these with the solderless breadboard, they tend to pop out. Things will just kind of pop out and wander around. But once you get them to the actual, surface. Actually, I think we should do circular pins on this too. So that's going to be replaced with this other microcontroller of the same type. And we'll keep the square headers on this one because this works with solderless breadboard better. But the next thing this thing is going to do is go into here. So that will get its own thing. Yeah, okay, I'm up to date with chat because it's not moving. All right, so we need a bunch of these things. That'll probably be enough. And then we use the solderless breadboard to solder on the headers because this will act as a heat sink and it keeps us from melting everything. So I need 3 of 2. I guess we'll use the clippers on that. I don't know about what the current specs are for these. How much current they can actually handle. This is like cutting uneven. I don't know if doing it that way or just breaking them is better. Maybe if I break them just very carefully. I know there's a fuck around and find out sign on your desk, but you might have troubles with them grounds. We're gonna find out. Yeah, that's the phase we're gonna go into. You're right. You're absolutely right, and that's why the sign exists. Remember, I am a Twitch entertainer, not a professional engineer. I have credentials, but... Although in this country, all you have to do is get paid for an engineering job to call yourself an engineer. Is there really only 4 pins? I guess so. The other one's 5. For some reason, Paloli thought it would be totally awesome to move that power good pin. Ow, that hurt. Yep. I almost said exactly the right amount. Now, I think they mean for it to go this way, so I think I am going to do it this way just so we don't confuse ourselves. That way, all of the labels are going to be on the top. I don't know if this one can swing that. The last time we put these in that direction, it blew up my power supply. Oh, I need one more pin. This one is 5. I meshed up. So if I did it this way, I wouldn't really be able to get it into the board. And what we ran into last time, Code Rush raiding with a party of 7. How's it going? So once again, I started the stream thinking that I was going to do one thing and then discovered that everything was wrong and I couldn't do that. We were originally going to use these power supplies that make plus minus 12 volts, but these are only good up to 250 milliamps, which means our totally awesome screen, our VFD display, wouldn't have enough current to run at all. These are only 250 milliamp capable. These were like an easy solution to a problem that I hadn't had a while back, which was I wanted a little stand where I could put the module in and just power it up. I was going to make something like that with this. Oh well. So what that means is that I need a fully fledged power supply that uses 3 different power supply modules in order to make plus 5 volts, plus 12 volts, and minus 12 volts. Because it's Eurorack, when it all gets to the connector, all those grounds are mixed together. The scheme for measuring the current coming from that, because really our goal is to have a front panel on my module testing module that has 3 volt and amp meters, one for plus 5, one for plus 12, and one for minus 12. That way, when I plug in a foreign module, I will know if it is totally bricked. If it's all bricked up, it's going to be using a lot of current, and then I will be able to see that current and know to turn everything off, which will probably be bad for the screen, but whatever. I can turn everything off and then get the module out of there and see what's getting hot. So in order to, foster that capability, we need the screen, we need all of our ins and outs, we need our plus minus 12 volts, we need power that specifically goes to the modules so that we can measure how much current those different lines are using. So what we end up doing is measuring the low side current coming back into an individual power supply. The problem that I'm thinking we'll probably have is if everything else in here is using that same supply, but that other use will be coming back on an unmeasured ground. So the internal ground will be different from the external ground. But no, that's not going to work, is it? Oh boy. So here's the problem: is that most of these negative powers are coming back. Sorry, most of these powers are they're sharing grounds. Everything shares the ground, and most of these current monitors are low side current monitors. So as a low side current monitor, we got to remember our circuit loops, right? As a low side current monitor, it's measuring everything coming back on the ground pin. A Pico PSU is a 12 minus 12 and a 5, and it's easy to break out because it's just an ATX header. I'm not using an ATX header. I have a Pico PSU, but I'm not going to use it. It's a 140 watt power supply. But what is that? Why are you telling me this? Why are you telling me this? Why do people feel the need to tell me to do something completely different from what I'm doing? You asked about the headers. The circular pin headers. The solderless breadboard is 1 amp. So I guess the headers are probably around an amp too. Yeah. At 25C, you can probably pull a lot more, but they'll heat up. Yeah, and then when they heat up, they heat more. So this is the scheme, and this comes from a couple other places. Namely, this is one of them. If you have separate power supplies, you can measure the current on that specific power supply. The thing is, we've got a couple things going on here, because we're trying to measure the power that's just going to the modules, like that's going to like a Eurorack module, not the power supply module. We want to measure the current that's being fed to, or coming back from, in this case, the Eurorack modules. But if we tap in on this ground here, yeah, no, that's going to loop locally. Yeah, okay, so that loops through that load, and then this loops through this load. and then whatever's distributed is going to come back this way. So that will still measure the individual, because it'll still be within its loop. There's a separate loop here for this. This will work. This will still work. Does anybody want to suggest something out of left field for me? Father, what if you buy beachfront property? Do we want to just get that out of the way? And I'll get frustrated, and then I can go back to what I was doing. So this will work. We're going to try this. And we'll see if we can characterize it a little bit and see how accurate it is. I'm going to continue on with my build. Should I actually be using the CAD program you prefer? Or maybe your IDE, right? Do you guys have an IDE to suggest? I'm about to pop my stack. Fucking chat. I don't care if that's not a phrase. I'm using it. I'm going to put the female header on this one, and that'll just make it a little bit taller. Perhaps also a baller. So that'll just get 2. It wasn't a serious question. Just whenever I use an IDE to do anything, everybody's got a different suggestion of what I should be using. Wait, why don't you use the program I use? I don't have an answer for that. Nor am I obligated to. So the problem with having this like this is that the capacitors on the top here will short out traces. And if those traces happen to have a ground on it, it'll burn up your caps. This has happened to me before. So I will put a piece of Kapton tape on the bottom of this. Actually, I should just do that right now. This power supply can get very hot, so you got to be careful about that. But it does have holes for standoffs. So if you're 3D printing something, you can put a couple standoffs on it, and then you can just have this thing hanging out. So yeah, let's get a little piece of Kapton tape on top. Where's my Kapton tape? Oh, it's over here. Why does it hurt? Okay, there we go. What size am I doing? Let's do this, and we'll just cut away the little bits of excess. We gotta get a little piece of Kapton tape on this thing so that it doesn't burn us in the future. It'll burn us to the ground. Get a little bit of that. A little snippy. Yeah, somebody always says, "Oh, Captain, my Captain," whenever I talk about Kapton tape. Kapton. It is a good tape. And I really wish somebody would take copper sheeting, thin, tin foil, copper foil sheeting, and use this glue on it. Because the copper stuff that I've been able to find, and by the way, chat, don't suggest anything because I've tried a bunch, and you guys all think you know that XYZ linked product uses the same glue as this. And then there's no other evidence of it because you guys are half paying attention and you don't know what I'm actually looking for. I am looking for copper foil with whatever adhesive Kapton tape has, because every single one I buy, I put the copper tape down, I cut like a trace out of it, and I go to solder it, and then the glue turns into soup, and it just starts wandering all over the place. Unlike Kapton tape, where I'm sitting at like a flash forge with molten metal dripping down, and the tape doesn't give a shit. Like, this stuff rules. It is super good at withstanding heat. But like, I know copper would be just fine. It's just that the other, that adhesive, whatever that is, double-sided Kapton tape might be good for that application. But then still, I would have to have unclad copper, unadhesive added copper in order to utilize it in that way. So it's just been a search for me. I can't find, I don't think anybody makes it, which is weird because when you do stained glass, you use copper tape in that way. You put the copper tape on everything and it's like a gasket of solder around your pane of glass. But then the soup glue is apparently totally fine. I've visceral, palpable frustration about this. And the thing is, copper tape is not cheap, so every time I experiment, I'm in for a financial hit. Which is why, at current date, I'm not taking suggestions, unless it is a silver bullet. Like, everybody loves to casually throw me links about that, and they're all wrong. Oh my god, this cutting is not going as well as I thought. There we go. All right, so now these have little Captain Tape bumpers on the top. What is the Captain Tape good for in this application? The Captain itself, the plastic high temperature material that peels up clean, will insulate the metal of the capacitor from any future application where it is hitting the vias on the perforated prototyping board. So this going upside down means that I can read the silkscreen labels, but last time I did that, I didn't give it ample space separation from the board, and there was a ground trace that went right through it, and it shorted out and blew up the $20 voltage regulator. That was in the steering wheel project. So what I've done now is I've put Captain Tape on the tips of the caps, so they have little bumpers. Yeah, Captain is a brand name. It's 3M. Or no, DuPont, actually. Isn't DuPont the owner of that? New EE engineering students, when I was going to DeVry before I ran out of money and joined the U.S. Air Force, they discovered how funny that reverse biasing a big electrolytic capacitor was. Some did it too. The joke was on them when they realized that those are not cheap. Yeah. There was advice in the troubleshooting analog electronics book that I had, I'm still reading it. If a capacitor is the size of a shotgun shell, it can have the energy of a shotgun shell. So you don't really want to go around busting caps all over the place. That takes on different meaning when I say it like that, but you don't want to blow up your caps all over the place. While it may be funny and it may get you a viral video, there's a lot of energy in that. Like, I was close to losing a fucking eye when that cap went off when we were doing motor stuff. None of you were around then. That was before all of you were born, when I was streaming for like 4 people. But that clip got 70,000 views in a week. That sure was neato. But yeah, that tape is really good and really light. It's really good at, like, a wiring harness on a spaceship uses Captain Tape. It's good stuff. It's very temperature stable, which is why we use it in soldering as a masking element, as a holding down element because it peels up clean, and an insulative element. So we put it under stuff that could conduct in our small tests like this, and we put it on things that we want to mask. I'll put it on vias and then glue an IC to it and do a little dead bug kind of thing with it. It is a very useful substance. It has 1,001 uses. It's very good tape. I wish I could find it with copper on the top instead, and we just can't. Is that actual DuPont brand? I don't know. I don't remember. I bought a bunch on Amazon, so I didn't have to think about it. Over the years, I just got used to wearing eye protection. Don't care how macho or silly. Yeah, the whole macho thing in safety is so stupid. Those damn seatbelts look so stupid. Dies. Like, come on. There couldn't be a more embarrassing death than when it's for a piece of safety equipment that could have saved your life. I'm not going to wear that damn noose, says Dale Earnhardt right before crashing into the sidewall and fucking his neck apart without a Hans device. Stupid. It's like the dumbest fucking way to die. Hey, Dale, we made this device that keeps the weight of your brain from separating your neck muscle like opening a can of pop. Cool, it looks stupid, so I'm gonna go die. Bye. Like, fuck off. Adhesive trace tape. Yeah, I mean, maybe if I look specifically for that. I had it in the 70s and 80s, if not, skip what I'm saying. I couldn't find anything like that, and maybe that keyword is what would clue me into it. Why is that not showing up on the screen? What's going on? What's up with my overlay here? I need to refresh cache of the page. That should fix it. Got both this and this. Yeah, maybe I'll look for adhesive trace tape if that's still a product. Probably had asbestos in it or something, so they don't make it anymore. The gravel stone you almost lost an eye to? Damn. Oh yeah, let's get a little closer for this. Chat, why don't we get a little closer, huh? Why don't you come on over here? Why don't you guys just come on over here? Park it over here. Scooch a little bit, yeah? There we go. And there's all the chat messages. If you were wondering why I'm babbling incoherently, it's because I have people that I'm talking to. And we just sustained a head injury. Let's just undo that. Yeah. All right, little Pololu regulator. Now, you know what? I'm actually going to reverse this just so that I can get the soldering iron in there. So, plant that little sucker right there. Now this, like that, is crooked, but what we'll do is we will solder one of the pins, and then I will arrange it. Still available, but not as prevalent. Is it super expensive? Because maybe I'll pick up some of it. Or is it like over specialized, or is all the stock from 1985? It seems like it should be a very useful thing for repair, but I just don't see it. How's that look? A little crooked, huh? Yeah, a little crooked. That's better. And then this is not better at all. No, sir. I mean, it's okay, but when installed, it'll be like that. So, can't get it right. Can't hold a note. Can't carry a tune. All right, there we go. Perfect. Third time's the charm. You can also disguise the safety glasses and make them like cool guy glasses. Although cool guy glasses don't cover all the angles of damage. And there was a macho thing involved. Shake hands with danger. Guy ought to know. Now he's named Three Finger Joe. That's a great video if you guys haven't seen it. It's called Shake Hands with Danger. It's a 1970s cat construction safety film, and they do a lot of incredible stunts. There were people in genuine danger on those fucking things. On those stunts that they did with like forklifts and shit. It's a good video. What is it? AV Freaks is the YouTube channel that brought that to us. And then Riff Tracks, the guys from MST3K, did a short on it and kind of popularized it. And it is fun as hell. All right, cool. So there's our 12-volt regulator. There's a lot of I/O on it, but we should be all right. We could probably eventually do this power good to an LED. So I could have a little LED that indicates that power's doing okay. So then let's see here. We got our 5-volt regulator. So we're going to get that one on a thing. And because this thing is so short, we don't need to have another header on it. We can just do it directly. I like to solder this one facing the board, although I don't know if that's a great idea. Maybe this one should be the one facing the board. I don't know which one generally to do. It'll stay in its socket, and you can't pull this vertically off if you do it this way. If you do it the other way, I guess the plastic could slide off. Yeah. Don't play your cards right. Dog's barking. What you got to bark at, dog? Usually people coming and going is... Let's go over to this side because I can't solder in the right hand, so I gotta make sure this thing is lined properly. And then once I solder it, I've got to align this one again too. Oh, focus. We're a little bit lower on the board, and the focal point of this camera is like 1 millimeter, so that'll do it to you. Man, I built a lot of power supplies with these modules from Pololu. Steering wheel is the more famous example. That thing absolutely uses a ton of... Oh, wow, that was still molten, and I totally screwed it up. It uses a ton of power to do what it does. And so I've got a bunch of these power supply modules for 12 volts and 5 volts on there. Not as comprehensive as the Eurorack standard, but it's still a lot of voltages to have to deal with. And there's all kinds of converters all over the thing. Especially with the LIN bus stuff. That was always a little weird. Why is that one pin different from the others? Why are you so different, huh? What do you got to hide? What are you talking about? I think the one header is loose over here. That's why this is moving like this. It shouldn't move that freely. Weird. All right, well, let's just move that in then. Weird. Okay, whatever. I'm just going to send it. Solder it, send it. Or not. It's a big trace. It carries a lot of heat with it. You got to put a lot of heat on stuff like this because all that heat is bleeding off into the ground plane right now. That one didn't do too bad. Traditionally, what you're trying to do is heat up the pin and the pad, and then the solder is applied to that. Sometimes that can get kind of hard to get going. You need to make sure your tip is clean. I use a dry sponge. It's basically just a brass thing. It's not Scotch-Brite, but anyway, you're trying to get good contact between these things. Now, these are tinned. They have a lot of stuff there. So you basically can sink the soldering iron into that solder, and it'll actually help you out. If it's untinned, you can have a little trouble. You can hold your soldering iron here, and nothing will happen for a little while. And so in that case, it is actually okay to tap the solder just up against the tip a little bit. And what'll happen is that'll release the rosin core of the solder and hold your heat in. One of the functions of flux and or rosin is to hold heat in by coating everything. It'll also keep things from oxidizing and give you a shinier solder appearance, but mainly holding heat in makes it go in nice and smooth. The thing is, like, so my iron is 300 watts. Not all irons are going to be like that, and people may struggle with it. And I've had that iron do that before. I'm not saying that the iron is currently doing it. I'm saying it's just possible that it happens. Do I want this one to be upside down? I guess I do. I've done the other ones upside down, but that's going to mean I need headers and I need to insulate the capacitors on this. So let's do that. Some of those chemicals are really bad. If you guys do to bother with the PPE, because I thought enough was really incredulous at that stupidity and all those classes telling us how bad that stuff is. I mean, yeah, but we're in my house. 737s, holy shit. Yeah, we'll put this one in the socket too because I've blown these modules up before, and I just want to make sure I don't blow them up again. Although I thought I had different sockets, but we'll use this. We'll use this one that I have. Okay, so some of these. Actually, no, break them. This one has a, I guess, more even splitting capability. It does better with these headers. It doesn't like, it gets it right in the middle and doesn't expose one. The flush cutters are good at cutting flush. They're not, I guess, good at separating out headers. For some reason, my wire cutters are way more consistent about that. This is going to be weird because this one has to kind of sit on top of a table with 4 legs for us to solder. I had trouble with it when I did it last time. This is as visual asthma soldering stream. Solder and chill. When I solder stuff, it's usually a violent affair, and I try to make it shouty and fun. Because otherwise, we're just kind of quietly sitting here. I still don't understand what somebody would do with an ultraviolet emitter on their flashlight. Like, I have a high-power ultraviolet flashlight, and I use it for 2 things. One is setting glue, and the other one is setting 3D prints glue. I don't use it for anything else. I mean, I guess if you're inspecting money, but like you have this pocket flashlight that's supposed to be an everyday carry item, and it emits ultraviolet, and it's just an ultraviolet LED. It's not anything fancy like the one that I have that has an actual filter in front of it, so that it's only doing ultraviolet. Ultraviolet LEDs are not very efficient. They output frequencies that you don't necessarily want. But like these flashlights that I was looking up earlier, they have ultraviolet on them. Why? What are these guys doing with these flashlights? Are they out there like inspecting for bodily fluids everywhere? It's like, I don't generally find myself at crime scenes. The crime scenes are found later, but I don't generally find myself at them. It's funny, this thing gives you all this provision for soldering it from the side. The only thing is, on the boards that I'm going to use, if I were to solder it from the side, it would be shorting out. No, it wouldn't be shorting out. It would actually be skipping over those. Maybe that's how this installs in the end. That would be much flatter. I can't do that with all of them, though, so maybe I just won't do it with this one. Mechanics use it to diagnose coolant leaks. I guess that's a pretty good one. They light up tomato hornworms if you have them. Pete Newcomb, I would like to tell you right now that I do not have tomato hornworms. Actually, I might. I actually might. I haven't looked at our tomato plants lately. So they're hornworm status. Man, do I not want to be called hornworm. Hey, what's up, hornworm? Doesn't even sound like language words when I say it that way. Yeah, I don't think everybody's running out and doing hotel bed inspection. I got those 2 in wrong. I did that wrong. Flip them over. Or now flip these over. Whew. I've got arthritis bait. It's like, I don't want to know. Like, I don't want that knowledge. I don't want the burden of the ultraviolet knowledge. All right, so that thing's sitting on its little throne. Oh, we got to do Captain Tape first. Yeah, Captain Tape. That's stuck in my head now. And it will be for a while. Cut that. Just got to make sure these things don't short anything out. We're doing it this way just so that we can see the labeling on them, because otherwise I'm going to be confused. I don't know about how I want to install them in the final thing. I guess they'll go with the label side up. Everything will be like clear and labeled on the main circuit board. It would be nice if I had spread out even more than this for the final circuit, where I could build something big and like properly put labels on it with the label maker. And that way, if I ever have to bust the thing open again to do a repair, I'll know what everything is. Instead, I'm going to do things a little bit more compact than that. I'll still try to spread out, but I won't be able to do verbose labeling between functionality sections of the final design. It would be very cool if I could make like a module that has all the 6 inputs, and then a module that has, and then that module could be unplugged and tested at the bench. That's a great way to do custom circuits if it doesn't have to be space constricted. You know, a lot of these times I'll build something and it'll be this totally compact design, and I'll try to spread out a little bit, but when it comes down to like test equipment, you really want it to be super clear what everything does and be able to get to everything. And, oh, there's noise here. How do I get rid of that noise? I got to add a capacitor. Oh no, I don't have room to add a capacitor. So you don't want to run into that. Got to redesign the whole thing. And we're not bean counting, so it's not like we need to save on circuit board production. Although, to be fair, I could just design a circuit board for this and it would be a lot of CAD work. I have some of this stuff in CAD already, but it would be ultimately a much cleaner design and it wouldn't be expensive. It'd probably be $100 to get five boards of that size. Considering time is money and all that, how much money am I costing by doing what I'm doing right now? What's my salary here? 1 sub per 4 streams? I could be cooking something in the kitchen and filming that. All right, so those are insulated. Now we're going to drop them down on these pins. I am so much more confident around analog circuits after doing all that synth stuff. And we've done a lot of synth stuff. Why is this fitting funny? Ah, these need to be moved in by 1 row. You kind of get to know the circuits and start learning the structures of stuff and what you like and what you don't like, and how to kind of author a specific type of functionality. Like, I need this, that, and this, and so I need this module, this module, this module. Is this thing not 0.1 spaced? Is that what I'm running into here? No, I'm running into this capacitor getting in the way of the header. Yeah, that cap doesn't allow me to put the header in. Also, it doesn't look like it's properly spaced. I thought if this thing fit in, then whack! Lost them. Made a Wario noise when that happened. Wow! Yeah, see, like that? Huh. But then we go to that, and then yeah, it's an uneven fit. Weird. Yo, your fit's uneven. I guess we'll do outside of the header and then inside, because these can solder. They've got the ability to solder up to the side like that. That's so weird. Here, look at what I'm dealing with. Oops, that's not it. This. So, where is it? Oh, it's way over here. Yeah. So these can solder from the side, but they're not quite placed where in 0.1 inch header territory. This is where 0.1s lie. Like if I put this up against here, which is 0.1 inch spaced, that lines up there, but that doesn't line up there. It's in between rows. It's like super uneven. What the heck? Oh, let me get that lined up. Let me properly show. Oh, shaking too much here. Let's just carefully place this on these. Oh, and it doesn't line up that way either. What a bunch of piss. That's messed up. Oh, that's really annoying. So yeah, it's hard to line this thing up. So what I'll do, and because this capacitor comes all the way up to the edge, I can't fit a header right here. So I will just offset that one. And then we'll force it back into being 0.1. Why are you not finding that? Is that the right space? Yeah. There you go. So like that, and then these can be offset with a giant solder blob on them. How annoying. I mean, what if I moved... no, that doesn't work. Could I do all four like that? No. Because it's off by just enough. What? Very annoying. I am annoyed. Okay, we'll do it that way then. How annoying. I mean, you could get a fancy with like horizontal, right angle pins and stuff, but nah, we're not going to do that. I'm just going to do it this way. It'll just be a little annoying. That's all. You know what it is? It's one of these things where I'm not looking for a solution to my problems. I'm looking to commiserate. That's my whole stream. That's sort of the dichotomy of the whole stream. That's sort of what I'm looking for. That's where the friction is. This is ground, so it's not really going to want to solder. This whole board is going to be super hot because of this. Ooh, that's not working at all. More solder. Drown them. We'll come back to that mess. That hot mess. Warp shifter. What's happy apps? I can't believe, like, everything I put in the previous title is just completely wrong. The power supply modules that I bought were for much less current than what our screen even uses. So we don't need to come up with a current mirror circuit. That would have been nice, clever guy stuff to do today. We would have looked so smart, but instead we have 3 individual power supplies, which solves a lot of our problems and simplifies things quite a bit. So now I will be able to monitor current on my +5, my +12, and my -12 by using the low side current monitor modules. These are the cheap ones that you can get just about anywhere. Let's build up a couple headers on the 3rd module so that we can get it into this setup. And I think I'm going to redo all the wiring harness. Like, I think I want to have just I want to have individual plugs for them, but I think I might do a 5-pin DuPont for each one. All right, let's see. I need right angle header, and unfortunately I have too much of that stuff. Look at these things, these stupid right angle headers. They've got the header on the wrong side. You need to have the header on the long pin, because if you plug something into this, it'll have all this sticking out. And you can't plug stuff into the short end. Who's making these things? Why are they in such abundance? They're the wrong way around. Yeah, even Willow's mad at that. I can hear her barking upstairs. She's getting all hot under the collar about my header woes. You don't have to fight my fights, dog. All right, let's see here. Let's get some of this stuff in here. So we got the 2-pin for the current monitor, and we got the 3-pin for the voltage reference and power for the module itself. We're going to power all of these things from the 5-volt rail. Although technically, you know, if you really want to do it, they should probably get their own independent power supply. But we don't need to do that. Oh my goodness, she's freaking out. I think the mail lady's here. It just said, motion detected at the front door, and she goes, boo! She's really really mad. Hold on, why can't I just put these up against the edge, huh? Why is that illegal? I need to clean up this desk. I don't know when I'm going to be able to do it because we're on a streaming marathon. I'm going to be streaming tomorrow. I haven't set up all of the notifiers yet. And I forgot to get my recycling out, so I'm drowning in bottles. Seltzer bottles. Oh, the hovercrafts are here. Oh my God. That was the motion detection. I don't know how they're doing this season, the hovercrafts. You know, they made regionals last year, but, and you know, I'd let you guys know that, but I don't know how they're doing this season. I think they got a lot of new talent. You never know with new talent, you know? But we'll just have to see. I think they've got a couple scrums or something. What do you call a group of hovercrafts? What is that? Gotta be a word for that. A flotilla of hovercraft, or a... It's more of a chaos of hovercraft, let's be honest. Those things are not very steerable. I remember when, wasn't it like Sky Mall that had a hovercraft in its catalog? I wonder how many people bought that. You realize with a hovercraft, you are at the whim of a fan. You're basically a shuffleboard puck, or a whatever, air hockey puck with a fan, and that fan is supposed to point you in a direction. So if you have to turn, there's no incentive to stop your forward momentum, right? Now, we're talking about hovercrafts, not the hoverboard craze. Hoverboards are a big scam. All right, so VA in that direction. So VA, and then this, like this. There we go. There's got to be some, like, a disaster of hovercrafts. That's a good one. You can probably hear them in the background when I'm talking. A lot of various noises. Noise. Jeez, that was violent. All right, so that should be right side up. Should be. Yeah, all right. This is kind of a flimsy panel. It's a thin panel, so it doesn't need to be robust because there's no controls on it, nor do I want any controls on it. The power switch is in the back of this thing. I don't know if having a front power switch would be like a safety thing, but we're going to go with a rear power switch. Soldering tips, if you roll back the VOD a little bit, I gave quite a few tips actually when I started soldering this one. I gave beginner's tips when I was soldering this. So just roll back the VOD a little bit and you'll be able to see them, hear them. It's all about, you know, how you apply the heat to the pin. But there's 1,001 videos on the internet about how to do that. I am particularly skilled in soldering. I should put together my techniques, you know, the Oh Bother's techniques shorts or something like that, because everybody has different techniques and they're all going to tell you to do different stuff. Basically, just like welding, seat time is everything. Just get out there and practice. Find stuff you can practice with. Old motherboards, broken power supplies, stuff like that. Power supplies are going to have a lot of very heavy traces on it, so that's going to be a little bit more difficult. Motherboards, modern motherboards aren't going to be very good either. Old 90s, early 2000s stuff maybe. What are you going to find? What's going to be the best? Yeah, you got to find like... Well, it all depends on where your derelict electronics are coming from. Derelict my balls. It depends on where your derelict donor electronics are coming from. But you want to find stuff with lots of big components on it that you can... VOD is only available after stream. No, you can actually click through. It's kind of a little annoying to click through, but you can click through and look at my videos section on Twitch, and then you can click into this video, and I think it'll allow you to rewind at that point. You can also do @OBotherVOD on YouTube, and I think you can click onto the stream and then rewind it. YouTube does have a much better video player than Twitch, but it doesn't have the community, the sense of community. I literally fixed my toaster oven because of soldering stuff that I've learned here. Hell yeah, brother! I love to hear stuff like that. That's exactly what I love to hear. That's like crack to my veins. That's like my crack. Wait a minute, what? What is he talking about? Why is he talking about his crack? What is this? What is this show that I'm watching? Somebody learned about their crack? What does that even mean? There's like an era of electronics where it's really easy to get donor stuff. Unfortunately, if you go to computer stuff now, everything is the absolute small size because we're putting stuff together with robots, and you know we've got all this advanced technology and all these ASICs that are doing such specific tasks that you have to program each individual chip with like a serial number. Everything is crap. That's not to say, it just means it's harder to learn soldering off of that if you don't have sacrificial stuff. So where to find appropriate era sacrificial stuff is kind of beyond me. I don't know. Maybe you can find like a Goodwill or something and find some old speakers that you can take apart, stuff like that. I don't know. But what I'm saying is, like, aside from the soldering techniques, just having the stuff to practice with so that you can get familiar with how things work. And over time, solder crystallizes and hardens. So you'll have to add a little bit of solder to alloy the solder that's on that pad. There's a lot of techniques like that come up organically in this stream. It would be good if I could put together a couple scripts, but you know, YouTube is completely inundated with how-tos. All of the techniques that I use here are probably parroted in somebody else's YouTube video that has much better production value. That's just the way it is. I don't know who to recommend for that, but you know, that's just how it is. If I do that, I am putting a drop into the bucket of how-tos on YouTube. Although having the Twitch stream going on and having to field that question every now and then, it would be good if I could put that together and just point somebody towards like a whole video series of things like, this is how I do stuff. Tell me why I'm wrong in the comments. Make me very frustrated. Yeah. Mr. Solder Fix, there's a good recommendation. Go check that out. I don't know who that is, but you know, I trust my chat. I trust them. I hope that when you click on Mr. Solder Fix, you don't witness a nuclear explosion and then die at your computer while playing Minecraft. But, you know, I've invented that suggestion out. Also fixed my partner's dad old iPod Touch from Stuff Here and Louis Rossmann, cheap hot air station on Amazon, and a lot of flux. Put a new lightning port on it. Ah, hell yeah. Those ports can sometimes be so obnoxious to fix. We did Octojay's folks' tablets, a little fixer-upper on those ports, and they were supremely annoying because, first of all, it was absolutely impossible to find what those components were. And now I've got a whole bunch of USB-C plugs, and I barely ever design circuit boards. I need to design a circuit board to use those USB-C plugs. But yeah, we did a whole bunch of stuff with that, and it was pretty cool, but boy, oh boy, is that annoying. Okay, so let's put together the little current monitoring setup here. So I'm just going to put these over here, and we'll connect all of the power supplies to the rails. I don't want to, see, the thing is, I don't want to bend these wires too much, because they'll pop off. They're not on connectors. They're just soldered directly to headers, which means that when the wire flexes, it is flexing the internal wire and not the jacket. Now, chat, you have to understand, and I have to tell you about this very directly. Apparently, I need to reiterate it a lot, is that the things that I talk about are not for you. They're for the beginners. I try to go back and talk about things that are assumed by most of us. So when it sounds like I'm talking about something you already know, or when I'm talking about something that, like, it sounds like I'm saying that I'm not good at something. It's me talking to the beginners and not you, because I need mass appeal to this show. I can't have a show for experts because there will be 2 people in the audience. I need to have a show for everybody because most of my commentary on how I'm doing with streaming is, you say a lot of stuff real good, Electronics Man. I like your show. And I'm like, thank you, but I'm trying to get you to understand. I try. They say, he talks stuff that I don't understand all day. And I don't know what he's saying. And I'm like, but that's not my goal. Me learning from Father every stream. Hey, I'm proud of you. Thank you. Thank you for allowing me to teach you stuff. So you're the expert on streaming. I mean, I got the check mark next to my name, you know? Although that doesn't take too much these days. How's it going, Malcolm? How you doing? There are better streamers out there, that's for sure. There are people who do less and have more viewers than me. I need something to go viral. I need it. I need numbers. My numbers are terrible. That's not that big of a deal. Here I am bitching about numbers again. I gotta stop doing that. Man, these headers are not in good shape. You can see all the solder blobs. You see, when you do something like this, if you want it to last a little longer than one test, if you put shrink wrap around it, that will then strengthen it a little bit so that when you're bending it at the jacket. The jacket is there to prevent that wire from bending directly, and that'll keep it from breaking off. The fact that we also soldered it makes it a little solidified, which means that if it bends at the solidified part, it has more of a chance to shear off. You know, one of the other ways to do it is a dabble of hot glue. Hot glue, push it down and get it in there. And then that will insulate it and hold on to the jacket instead of the wire itself bending. And then the proper way to do this would be to crimp something on the end of the wire, but that takes a lot of time. I don't want to do that. Things are not going well. Oh no. Started browsing Marketplace for 3D printers. Oh no. Then I looked at reviews and now I'm looking at new printers for 3 times as much. Oh God. I decided instead of putting all of that cost up front, that I would slowly upgrade my own printer piecemeal until it's some kind of a Frankensteinian POS, and then I would be out thousands of dollars but not really realize it because it would be over the course of time. That's my strategy with 3D printing. We have a 3D printing section in the Discord, and they are a big help to a lot of different people. All right, so what we need to do is hook these 3 up to ground and power from the outside world. So, how am I going to do that? Oh, and I also need a current source, something to leak current, but that'll be over here, and we'll try to find like a resistor for each of them. I got the replace itch for my current printer. I've got an OG Ender 3 Pro. My friend won't stop talking about his Bamboo Labs P1S. Yeah, those Bamboo Lab ones people are talking about lately. I don't know to what end. I don't know if it's frustration or if they actually make a good printer. I would have to assume that they do. All right, V plus goes over here. All right, let's get this on the. I'm gonna do this on the scope, I think, so I don't have to squint down. Oh God, it's the smell of cut grass and allergies. I landed on the Bamboo P1S after a bit, huh? Yeah, my whole thing is I just got the resin printer. I haven't like done anything with it yet. I really should do something with the resin printer. We're gonna do plus and minus coming in from here, and then we'll do jumpers for everything else. Big old jumpers for everything else. Big yumpers. So I'm positive we got to go into VN. This is as simple as it could possibly be. It's as simple as can be. Positive into VN, ground into minus. I need jumpers. Tweezers. Tweezers help. Some of these old kits, the old breadboarding kits, had this great pair of tweezers with it that were like a little grippy. They had like kind of a flat grippy on the end. They were great tweezers. They were like big tweezers that were grippy. I gotta find those because those are great for breadboarding. You can really maneuver everything. The ones I have are not grippy, but they're the sort of blunt-ended tweezers. These are like a second pair of hands to me. I can manipulate anything with them. The pointy tweezers are not something that you want to be using for electronics like this. If you're building surface mount, you don't want to use pointy tweezers because they can tend to do this. And when they do this, what they're doing is they're flicking the part, and the part just goes and disappears. It'll go directly into the cat dimension at about 10,000 miles an hour. Never to be seen again. Input. This one. This one has a lot of power behind it, and I'm a little hesitant about using it here, but it's the only 12-volt regulator that I think I have. You know, a 2 amp would be fine. I think this thing goes up to 5. It's got like 5 amps. Creality K1C. Built-in head-to-head article. Huh. Yeah, I don't know much about nothing at this point in terms of printers and stuff. I guess I can't go in directly, so what I'll do is this, and then I'll do a skip over. Yeah, they warn you that you can burn yourself by touching this power supply. It's very efficient. It's one of these extremely efficient power supplies, but still. Comes with a caveat. So B+. There. Oh, that's not very efficient. Yeah. Just like that. Okay, we'll go from there. And then, of course, ground. Well, ground can come up and over. I'm just eyeballing this. I'm balling. I'm just balling it. Free balling it. That'll do. Power and ground. There we go. So everybody's now hooked up to power and ground appropriately. Now we have our outputs. Our grounds are still our grounds, but we're measuring across them. So each one of these grounds over here on the output needs to be separated out per module. That one shares the ground with the input and the output. I don't think that affects us. No, that doesn't affect us. Okay, all right. Even though they're shared grounds, we're still taking the grounds from each module and moving them over. But wait a minute, but doesn't that mean that they're just shared anyway? Oh man, these fucking things. No, but they are isolated because those grounds meet up after and it splits up, and then the power loop looks like... We gotta just test it. We'll just test it and see if this is all fucked up. I'm so annoyed. I'm so mad. We're not testing the module's current. We're testing the current that goes out to... Oh man, whatever we have hooked up. I keep second guessing. Well, let's just do it anyway. Do it the way we need to do it. So it'll be plus minus 5. So this is minus. So that goes to the black wire. Well, actually, we should do these two. Hold on, let's hook these up. Hook all these up to their powers and stuff. Down here. So the red wire and the black wire are not connected to each other on these except for the 5-volt module. So the 5-volt module gets the two of these connected, which I can use a one jumper, which I had a couple. What happened to them? Where did they go? I'll get the scissors out of here before I poke myself, before I perforate thyself. Where are my jumpers? Yo, where'd they go? Where did they go? They're probably like under everything because I've been working on top of a pile of crap for a while. Too long. For too long, I've been working on top of a pile of crap. I could have sworn that in the new X-Men '97, the voice of Magneto sounded like the voice of the Pakleds from Star Trek Lower Decks. It has the same, like, accent, whatever that accent is, and they talk in a similar, like, you know, blah, 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 kind of manner. I thought that was the same voice actor. I looked it up, and there's no connection at all. It's some dude who does a lot of video game voices. A lot of video game voices. Where did those jumpers go, man? Son of a bitch. I had a bunch. They were right here. I put them somewhere probably, and now I can't. Ah! I found where I put them. No, I found where I put one. Ah, thought I had more. All right, that's okay. We'll use this one. So on the 5 volt, we do in fact bridge these because they are both connected to 5 volts, our 5 volt source. Be able to see if it drops down for everybody. Then mains ground? No. This is different. This is much different. You are confused. Okay, so we take that 5 volts and we put it to all of the red wires. So all the red wires get 5 volts. Red wire to 5. This one here, that's 5 volts. These just need their own independent, stable power. They can be powered off of the circuit itself, but this is just a way to make sure that they all get 5 volts properly. Now, if they are measuring that voltage and that voltage drops down, then things don't work so well. But they appreciate the isolation. In that guy's circuit, the circuit that I was looking at for this, oh wait, that's distance, oh I see. I put that a little closer on that one, and that's why, well, I guess we could move this one. That's why the yellow wire worked. Because it's just a little bit closer. So those will eventually get 5 volts into them. That's good there. Grounds here, grounds here, grounds here. Are those just going to be shorted with this ground? And if they are, I guess they are. What's that? What wire am I going to put there? Move that in to be just one block space. Could you? There we go. All right, so let me find a yumper that will do. Whoop. That's what I don't like about these with the no grip on them, is that when I grab a wire with these and I squeeze too hard, it'll either throw the wire out or just the wire just kind of twists to wherever it wants to go. Actually, it's going to be yellow wire, isn't it, for all of them? Nothing, maybe. Get away with this. Orange was close. Orange was originally going to work when things were spaced out more, but now it won't. I guess it needs to go here, here, here. Man, that's a lot of jumping. That's a lot of yumping. I could yump it backwards and take it to the rail. Oh no, but I don't want to rail it off because we're trying to measure the individual returns. Or does it matter that that's like that? Does it matter? Because we're relying on these things to split up the current between them as the supply to the individual module. Yeah, that doesn't work. I need a larger jumper. No. Oh, good. Now it's 2-stroke fuel. So before it was the cut grass smell, which I don't particularly like. I know people like cut grass smell. I know people are freaks about it. But now it is 2-stroke exhaust getting down here. So now I'm going to get loopy with 2-stroke exhaust. I'm looking for one of the jumper kits. Don't know what. Ah, there they are. Okay. Now I got this thing. I have all the jumpers I could ever eat. So, like, if I connect all these grounds, yeah, you know what I'm going to do? I'm going to move these forward, and I'm just going to jump them back to ground. Jumping backwards to ground. It'll clean up the board a little bit. No, 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 no. I shouldn't need to do that. Well, I could just do boop, boop. Yeah, we'll do that. I'll do a little right angle thing on that. Because, like, they're all connected on the one side. Oh, no, wait a minute. No, 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 no. Yeah, those, no, they're not isolated grounds. They're all connected together. What a weird scheme. Okay, well, we'll see if this works. We're not at the find out stage yet. We're still effing around. Cool. Just, you know, just don't do what I wanted you to. Okay, get out of there. Get out of there, wire. Yeah, because we're talking about loops, right? We're not talking about the, well, specifically the ground. I don't, but it's, no, but if it's, if they're all connected, then it's all going to share ground. And if the grounds go through these modules, then our circuit is going to just be equivalent of all of these here being connected to one another all throughout. Because this ground is this ground, and this ground is this ground, and this ground is this ground. So then I'm not necessarily splitting off that specific modules. You can totally mow my lawn if that'd help. Are you that neighbor who goes, you can wash my car next? So I think we're not out of the high side, or the current mirror. I don't think we've actually worked our way out of that. Because these share grounds internally, it's literally just a trace. So what we would be measuring is a split of the ground coming back and going three ways. And it doesn't make it specific to that module because they all share all throughout. What a bunch of piss. Because that'll just be an even spread of all the currents. It's not, this one will provide outwards, but then it might get it back like through that loop. So indeed, we are boned. We have to do the high side. All right, so my title was right. Current mirror. Current mirror. Current mirror. We are going to use an op amp in order to turn current into voltage. And then we are going to use some kind of a thing to turn voltage back into current. And we will put that across the shunt of the panel monitor for +5 and +12. It is our only option. Took me a little while to get there. I had to step back from what we were doing. This is still useful, by the way. We'll still use this. It's just I'm going to have to move all this stuff in order to do 2 op-amp circuits on this board. That, or we can move to a different board. We might have to move to a different board to get a little bit more space to operate. But we got ±12 volts, so you got a haircut. I got all my hairs cut. It's that kind of humor, huh? We can be funny in different ways, right? That is to say, I don't lean into a good dad joke. And there are plenty. It's the problem with trying to be, like, light and humorous. Or, like, joking around with kids. Like, I'm not gonna make that joke around a kid. Instead, I'll talk like some stupid pun. I'll just do a dumb pun. How you doing? Ah, my legs, my stupid legs. Okay. Yeah, we changed gears a couple times today, and we've just got a little bit of a conundrum here. The problem is all of these current monitors that you can buy right now are pretty cheap. We looked it up. We tried to find, some kind of a panel monitor. The thing is, a lot of people are doing stuff with like solar and batteries and electric cars. And solar and batteries and electric cars deal with power cells. You want to know the current, you want to know the voltage, you want to know how the health of your cell is working. I'm going to cough. Oh my God, the air quality in here has to be terrible. You want to know that everything is rolling along just fine, and you've got plenty of energy stored in your massive power bank. Massive power banks operate at higher voltages because then you don't need as much metal to move the stuff around. It's a sort of a cost-benefit thing of going up to high voltage. They operate happily at these high voltages, and so the best way to be measuring current and stuff from things like that is to use ground, because then your electronics that are doing the measuring don't have to be hardened for thousands of volts, right? Even though they are measuring massive amounts of current coming back on it, you're basically doing a voltage drop across a resistor, but you are at ground potentials for the whole thing, for the whole shebang. So that's really where we see a lot of this stuff functioning. They're all operating at these low side current sensing. The problem with low side current sensing is that if you have some kind of a fault, if you accidentally apply ground to the positive rail of your circuit, you're not really going to see that fault. You're not going to see the current draw from that fault. You're going to see a drop in current. There's going to be nothing. That's a problem. That's a problem. So I need high side current drivers. I bought 3 low side current drivers. I can't find panel mounted in the specific style that we have high side current sensing units. So what we can do is use what's called a current mirror. Current mirror. Mirrors current. Now, current mirrors. The last time we saw a current mirror was actually fairly recently. We were working on, remember when Julian was here, we were working on the penis ladder filter, or diode ladder filter, if you want to call it the wrong thing. It's definitely a penis if you look up a ladder filter. Anyway, in audio, what that means is that we're using a bunch of transistors as diodes in order to filter frequencies through them. It's a little bit complicated, and it has to do with how much current is running through that tower of diodes. And in order to control the amount of current through the tower of diodes, you have what is essentially part of a current mirror circuit. So current mirror circuit, you can turn current into voltage and then turn voltage into current. You can achieve this with an op amp sensing the current across a resistor. They are all the same ground, yeah. You'd want an isolation transformer for each, and then a circuit ground on each, and then an optocouple. Stop. Just stop. Stop. We've already figured it out. Scrolling our dad jokes is my... All right, let's see. What's the penultimate dad joke? What is the penultimate dad joke? Hold on. Mission detected at the front door. Is it just dad joke or is it dad jokes? I hate you. I hate you. Hold on one sec. We got to get out of this layout. Why did it Google search that? Wait a minute. There we go. It's the second time it went through. By top of all time. The ultimate dad joke. Iran struck its own submarine with an underwater torpedo in the Persian Gulf, killing 350 aboard. Whoops, wrong sub. This is the ultimate dad joke. Is a specific thing to subreddits. There you have it. That's what I was looking for. There's the view. All All right, so we need a circuit that's going to be able to do that, right? Oof, no, I'm not reading back those. Okay, so let's do current mirror. Current mirror. You shut the hell up, AI. Nobody likes you anymore. You suck. You're fucking terrible at everything. Let's do op amp. Current mirror op amp from Minnesota. The problem with this current mirror stuff is it's all educational material from like classes. And like, I don't want class stuff. I want to just build a circuit. Oh God, no. Yeah, they're all like educational material. Chapter 11, the current mirror. Apparently a way to really destroy students via mathematics, which is essentially what they're trying to do in all these classes, is to put them up against current mirror setups. This is the article that I read a little bit of this. Input stage to convert, and then an output stage to convert back. So, I mean, you can do it with the transistors. What is the equation here? The final step to be connected to output of the input stage is the emitter junction of Q1. Emitter junction of Q1. The input to the output stage is the base emitter junction to Q2. Build a basic BJT current mirror circuit. I can get a couple 3904s, but I have a feeling doing something with op amps is going to be a little bit cleaner. Jeez, what is all this? That's with FETs. The basic one, but then do we get into op amps? This one doesn't get into op amps. Yeah, because there's probably a lot to this, but I'm looking for op amp ones. Current mirror op amp 12 volt. Back to the university class. Nope. Double the gain, current mirror. I don't want to double the gain. I want exactly the same gain. Ultra low voltage curved mirror op into applications. Maybe that's right. Go Bears. Sign in to continue reading. Ah. No, I don't need a paper. Jeez, come on. Wilson current mirror. Oh, so it's that kind. We're going to current mirror circuit, and I'm a little bit out of a problem. I have a current mirror circuit, which is supposed to do, well, mirror the current. Okay, thanks. Current the copy part has nothing to do with the original current, according to Circuit Lab. This is why I don't do simulation. So what's our input and output on that? If we're doing it with transistors, oh man, that's going to be kind of annoying. Band gap voltage with op amp, BJT. What? No. So let me see. I had some material in Discord. I was going to try to use some of that. Oops, that's the wrong thing that I clicked on. Yeah, this one's EV blog. And this one's the... Oh, that's the one that we just looked at? No, but this one has op amps. This one uses op amps. Oh, not entirely. I see. It uses it up here. Linear voltage to current converter from chapter 4. V in through there. What? That ain't look right. See, this is the example that I saw. Is same thing as they're using these guys, and then somebody suggested doing a current mirror, and so low power MOSFET current mirror. I don't know what the hell this means. 0 to 75 millivolt to DAC. We're not going to a DAC. We're going to another thing. So 15R to ground. You know, where do we fit into this? 15R, and then 1.5 mega ohm on the high side to the load. That seems like a lot of ohms for this. I guess, no, the rest would not get through there. What the heck? The idea was to change the sense resistor inside your meter to something much higher, let's say 150 ohm, and then use a current mirror with 1.5 milliohm resistor on the high side to convert the 50 amp current into 5 milliamps. But why would you restrict it so much through a 1.5 mega ohm resistor? You wouldn't be able to get your current. Where's your 50 amps getting through? That doesn't make any sense. Hall effect sensor, but bear in mind, needs a 5-volt power supply. I don't know. I think that circuit is completely irresponsibly wrong. So that's not right. So how the hell do we do this? So we need like a high side to low side. High side current mirror 12 volt. Analog devices current mirror. ADL 53 something or other. So what's the application? I don't want to have to buy another chip though. We've got plenty of op amps. The ADL 5315 is a wide input current range precision high side current mirror featuring a stable user adjustable input voltage. It is optimized for use with the pin photodiodes. What? But its flexibility and wide operating range make it suitable on a broad array of applications. This isn't going to be the right thing. I'm just kind of looking to see how people use these. Like, what is this? How do I use this? Where's an application note? Where's my application? No, don't care. Voltage supply, and then mirror current output. What's the input? What the hell? I don't want to dedicate brain space to something that I'm not going to be using in the end, so. VPOS, and then data path, linear voltage output. So this is basically converting current into voltage for a microcontroller of some type, which is not what we want, because we want something simple that's going to mirror the current and allow our meter to read that, which seems to be what the blogs were looking at. All the answers on the forums were leading to. 2 ohms, 3 watt current sense resistor, max current 0.7, and you're putting that into a transistor, I guess, as like a detector circuit. So this would be, that's 3906s, which has 24 transistors. I guess I don't see a way to sense 70 milliamps without amplification. Sense resistor 70 over 10 ohms. The only idea, I have to amplify the sense resistor's voltage, which can be done with 2 transistors. So you have 2 transistors there, and then your output's here. Does that mean that output goes to ground, or is that output's going to be like a voltage, and you'd want it to go through a resistor, and you would be sensing on the 2 sides of the shunt, but I've already got a shunt. So we need to do calculations here. Man, this has gotten a little bit complicated. So R01, that might be a B. I don't know if I can call that an 8. 018. So would that be 18 ohms? I don't think that's 18 ohms. Let me see if my multimeter is going to read that, just so we know what the shunt resistor is. Just so we know what it is, I'm going to put it on the meter, and we'll at least know what that looks like in our circuit. This has been incredibly annoying. Oh, I keep looking. So there's 3 of these things, right? And they're all in a row, and we're looking at this one, but I keep looking down and seeing the first one, and I don't get why I don't see my hands on screen. Like, did I become a vampire? Did that happen? There's another Windows update. What the fuck? Oh, god damn it. I don't want this machine to restart again. It's going to close all my applications and like smack me around. So this says half an ohm, so I don't really know what to trust. R018 I'm going to look up. CSM series? That's not it. Those are cool looking. It's a cool looking little piece of metal that you can solder in. No, those are super precise. RWN series. See, like with shunt resistors, there's all kinds of crazy products that you can get in order to put a big resistor, a big low value resistor in your current path. There's all kinds of really cool stuff. And I would love to use that kind of stuff, but it's a whole nother like category of expense that I got to figure out. It's to fix an IPv6 invulnerability, and it's important. Oh man, but it's gonna like smack me around. I don't want that. All right, let's get shunt out of there. It's been my favorite word. How do I still not have a solution to this problem? I'm mad. I'm actually mad because we thought we could go in one direction and then the other, and now we're back where we started from. These power supplies don't isolate the input ground. Everything is just ground. Everything is referenced to ground. And so we can't split off the ground from our individual power supply units without doing something funky. I could measure, what's up, Dog Vomit? Thank you. That's a great name. Thank you for subscribing. Oh, it's actually a gift sub. Anonymous. Giving to Dog Vomit, Esports Are for Losers, Rinstro, Temptic 404, and Chester Willard. You guys all, thanks to Anonymous, got subs. I appreciate, you know, I haven't seen more than like an individual sub in a while. So thank you. I really appreciate the gift subs. You guys are great. Yeah, we're kind of like treading water with this thing because the yak shaving is starting to become fractal. As we move in and look closer at what I want to do, we look close and we go, wait, what's that? That's another project. And, you know, zoom in and, oh, it's another full project. So what's happened is let it auto-update overnight, and it should repopulate all the windows you had open. It doesn't with AutoCAD. It misses some beats there. So what has happened? We're building a module tester module, right? A Eurorack stand that'll be able to test other modules. And this is going to ease up some of the operations here because I've struggled with that M303 quite a bit. And I want to kind of be able to go sequentially through the M303 and make sure that it's all functioning properly. Well, to do that, I need a bunch of activation signals. So it's like, well, I need a module tester module. So let's just put one together. And in order to do that, I needed to have the proper flair for it to be an oh bother project, right? We need to make it cool. So in order to make it cool, I use one of my VFD screens, and that means we can't use a certain power supply. If I'm making a module that's testing modules, I want to know how much current is going through my power supply, so I know if I'm arc welding a module to death, I know to turn things off or unplug it, right? So getting there means that we need to build our power supply and have 3 monitors on it. These are handy little screens that do current and voltage. They're these little square screens. They look nice. They got big numbers on them, and they'll tell you what the current flowing through a supply is if it has an isolated ground. If it doesn't have an isolated ground, that means everybody shares ground, and so every path is equal. Every path back to ground is just completely even and equal, which means we're not going to be able to measure low side current. We can't do that. The only place we can do that is with the minus 12 volts because that is isolated, and we're measuring things that are isolated. Otherwise, we measure everything. If you don't measure, basically what we would get is 1/3 of the current running through the module at each node. That's it. That's all we would see, which doesn't make any sense. And remember, the modular synthesizer shares all those ground pins are all one big cluster of pins. So we've got a situation here. None of this stuff appears to be working properly. We have to actually get into the realm of math for the sake of math and educational type materials in order to suss out what exactly we need to be doing here. You can convert current into voltage, and you can convert voltage into current. Voltage into current is actually a big component of the ladder filter, the Moog ladder filter. But Most of the circuits that I'm seeing, they're just using transistors, and I don't know if I trust that to be accurate and stable and all that stuff. So I'm looking up op-amp circuits, and there's a family of op-amp circuits that we can use. I need to find the appropriate one, and I need to figure out where we're going to be putting our current monitoring shunt of each display. Each display has 2 pins with thick wires coming out of it. What that's doing is you put it in the path of the electrons, and when V equals IR, when it hits that resistor, there will be a voltage drop across the resistor. You know the value of the resistor, you know the voltage drop, and you get amps out of it somehow. It's math. Basically, if you compare the two. So if we can use a comparator, we can figure this out. Last time I used -12 was for a 120 millimeter 48 volt fan in a computer. It was nice and quiet at 24 volts. Yeah, the 24 volt. Hello, Yak Human. Hi, NanoCat. How you doing? We are just obliterated. This yak is being atomized as we speak. So yeah, using 24 volts in a computer is all well and good. That -12 is there as like a dinosaur. It's like a relic of the systems that use, like audio systems using plus minus with the op amps. In our modular synthesizer, we are using plus and minus 12 volts. It just makes a lot of the op amp stuff easier if you have that rail-to-rail plus minus ground scheme going on. Generally, in other applications, you would do a DC offset, and so things would sit at 2.5 volts. You go up and down from 5. So, where's my mouse? It's on one of 3 screens. There it is. I need to find a circuit. I tried to find the value of the resistor, the shunt resistor, and I'm kind of striking out at that. It says 0.5 ohm, but I don't know if I trust that. Oh, is that 470 milliohm? Maybe that's what that is. 2 10Ks, 2 3906s, sharing the base, and then that goes to one leg, and then the other leg is the output, because it push-pulls between the two. And that looks incredibly linear, up to an amp. That's the voltage per, what's this, what's the 24 volt? That'd be ground to positive 12 if I really wanted it to be 24 volts. But then depending on the current, it goes down. Gain of 10. 0.47 volts to V out. So it goes all the way up. I don't know. I've seen some sound cards which use -5. I found this board, and I don't know where it came from, but it scares me because it has -5 on it. I found this just sitting around. Sanya Power ASIC, +5 volt, -5 volt. Where the hell did this thing come from? Sanya. I may have removed it from, oh, you know what? I think maybe this comes from something that had other switching stuff on it. And you break the board off. Did Sonya give it to me? Maybe. I don't remember when she was here. Weird. Okay, anyway, put this back. I think that cracked off of the bottom of another type of board that it had switching components on it, and you either needed that or not, and I didn't. I don't know. But okay, I'm struggling to find a circuit that would do what we needed to do. We basically need a high side current mirror that creates a low side current to monitor. High side current meter, low side current monitor. Don't you talk to me. High side current sensing and low side current sensing are 2 ways to place a current sense resistor in series with the load. Wow, thank you. High side and low side, resistive current sensing, high and low. That's not helping me. See, they always turn it into a V out to the systems. Ah! Amplifier consists of an op amp and 2 gain resistors. Yeah, R1 and R2 is basic amplifier circuit. This is what I was talking about with fault detection. That wasn't very helpful. Yeah, there's all kinds of articles about it too. I guess this is sort of the TI article. So that turns it into V0, and I guess maybe what I need to do is turn it into voltage across V0. So we would hook it up, and it would have the common ground, so the black wire would just go to ground. Positive would go to VO, and then it would be across the resistor that the shunt resistor that's included with the thing. And if we can get that to be kind of 1-to-1 with our system load, then that would be where, because we'd put the screen here. This would be, let's take a snip. Citizen snips. All right, let's see, snipping tool. Doink. Give me this. So we take that and we take it into our very advanced MS Paint and put it into our current mirror section. And so it would basically be this, but we would have the screen. We'll just take this one, +5 and +12. Take that. And this thing would be here. I'll redo a lot of this. The hovercrafts are zeroing in on my location. Oh my god! I don't want to yell, oh my god, and scare the poor guy. All right, so in this case, +5, +12, and then the 2 black wires would go to ground. I need that there. And then this would be the red wire. And the internal shunt is, I don't know, 0.5, I think. What I measured. So 0.5 ohms to ground, and that would be what we monitor. I heard the lawnmower as you were yelling. Yeah, that was good timing. You got to know when to do those bits because I have a compressor on my audio, so I have to make a noise and it'll activate the audio, and then you can hear the mower. It was very loud in here, and now it smells. So this would be then the voltage would translate into voltage across 0.5 ohms, and we would be pretty well isolated. We just need values for all this crap. All this BS that I got to put together in order to make a current mirror. A curve mirror. What are equations? Because that would then turn our high side into low side current sensing. Actually, it wouldn't take sides. It would just be sensing across this resistor. The resistor prefers being on the low side just because of the way the grounds are inside this device. I guess the black wire and both black wires share ground or something. I don't know. But this should isolate all our stuff out and allow us to, do everything we want, hopefully. What's going on my Pancreas channel? Oh, there's a new COVID vax that the FDA approved. Neat. Pentium 3 XP installation. That was always fun, though. At least, like, your operating system wouldn't be full of fucking spyware, legal spyware that exists just to fucking monitor every click that you make on your computer and possibly even monitor your microphone. Now when it randomly powers off. Okay, that's bad. That's kind of bad. I'm getting seltzer because clean water is all I got. I don't have clean air. It's like a groundskeeping shed in here right now. Are you using FCKGW? Load short to ground condition for low side and high side. Current sensing. What? That I can detect a load short to ground condition. Oh yeah. Blah 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 blah. TI, what are the equations here? What devices? What resistors and stuff should I be using? Now they want me to use the OPA 2992. It's probably a rail-to-rail op amp. Dual 40 volt, 10.6 megahertz rail-to-rail input-output, low offset voltage, low noise op amp. No thanks. We're going to use a TL072 because I need 2 of these current sensing things. While assembling my new PC, I found out EVGA gets to install malware for the MOBO that can brick itself with self-updating. Why? Why does that? What? Is that a new thing with frickin' MOBOs? Didn't you only need like basic drivers in the past? I used to force quit everything but Windows XP. Force quit everything but Windows and then play MechWarrior. And you'd get all these extra frames. Now you need to dedicate a hard drive to Call of Duty with uncompressed audio. Okay. Oh, VO equals gain plus 1 times V offset plus gain times V shunt. That's input offset. Oh, here we go. No, that's VCM V bus. Let's see. Operational amplifier requirements for high side current sensing. The common mode voltage of the operational amplifier must be considered when designing a high side current sensing circuit. The common mode voltage is set by the bus voltage and the resistor divider formed by resistor R1 and R2, and is calculated using equation 1. VCM. So the common mode voltage equals the bus voltage times R1 over R1 plus R2. That's not helping me settle on values. We may just have to copy one of the other ones, see how it performs. It's important that R1 and R4 matches closely with each other, as well as R2 and R3. Any mismatch can result in gain and CMRR errors. It's recommended to minimize these errors by using precision of 0.1-inch match resistors for the external circuit. The input offset voltage also may be considered when determining the solution's accuracy. The input offset voltage is inherent to the op amp and changes the expected output voltage as shown in equation 2. I don't understand anything I just read. That just completely leaked out of my ears. MSI can disable in BIOS. Ah, jeez. Hardware is getting to be a whole song and a dance, isn't it? It's a lot of crazy stuff you got to do. VO is equal to gain plus 1 V offset gain times V shunt. The error can be significant if the offset voltage is near the same value of the voltage across the shunt resistor. Op amps with intrinsically low offset voltages are recommended to minimize the error of the system. Table 1 shows recommendations that are all OPA except for the LM7322. Thank you, Texas Instruments. The benefit of the high side current sensing include reducing ground disturbance and okay, whatever. That's all this is. That's all that article is. It just says, hey, use these products to do this. I could really use like some initial values of this thing, although we have seen the circuit around. So let's look up like high side. So high side current mirror 12 volt, and we'll just see if we can get a good example circuit. 0.2 ohms. They put it through a transistor at the end, but that's 0 to 4.3 volts, and it's got a 3904, which we've got. The classic passive supply rail current sense. I like that it says classic. I'm going to go to this webpage. Oh my god. I guess that's what these products are. You can buy the ones that have the amps in it. And they're doing an isolation on that. The classic. The return of the classic. Got that 3904 in there. They seem to love putting that 3904 in there. Why do they do that? I learned today that if you don't I learned today that you don't have to use a dedicated part to do high side current sensing. You can do this with a plain old op amp. Yep, that's what we're getting at. This is news to me. That's news to me too. So I thought I'd write a post to introduce the other newbies to this idea. Please educate me. Yes. Disclaimer, this information isn't useful. Oh, okay. All right, bye. All right, let's go back to this. Isn't useful for making real products. The dedicated parts which do this can be had for under $1. The approach of interest for educational purpose and would be appropriate if it... Oh, he's just saying don't use this explanation to make a real product. I was browsing DigiKey, came across the CS30. In the datasheet, they show its functional representative and how the part works. RG1, RG2, RSense, voltage cross. For some reason, put it out to a transistor, and then we output it. And in our case, we were just going to be measuring across a resistor at the end there. But they got this 2K to ground, and we have a voltage coming out of here. And if we put our voltage directly to ground through our sense resistor, is that going to be too much current? 0 to 4.3 volts. That's a lot of volts. This is a 5-volt circuit with an LT 1637. Later, I came across this great app note from Linear about high side current sensing. Hello, where's the app note? Show me. Don't just give me this blank page. AN105 current sense isolation, making sense of current. Making sense of current. Making sense of current. What a joke. God damn it. We got comedians writing these things. Sensing and controlling current flows is a fundamental requirement of circuits organized by general application. Each chapter collects together applications that tend to solve similar general problem. Okay. Current sense basics, low side current sensing. Okay. Neat. Yeah, that's essentially what we do. Oh yeah, we have to incorporate our load into this, don't we? That sounds really bad. I probably should phrase that a little bit differently, but I mean, we do have a load. Our system has a load on it. Is that what we're using our ultraviolet flashlights for? I forgot my load. So in this sense, the load... Actually, no, the load's over here. Yeah, that's where the load is. It's over here. So these go out to everybody else. This goes out to all my DJs. Do-do-do-do. Making moves out on the dance floor. Nada, Craig, David, and he's real hardcore. From the front to the back, that's where I was at. You know, the Artful Dodger do like that. With Craig David all over her, boink. DJ's all up to you. Okay, this, that, and then it gets more and more complicated, and then it turns into a word avalanche, and you end up with something like this. So let's just go ahead and steal this. Snip! Well, actually, that's the same circuit. It's just this one has a transistor on it. Which, I guess, I don't know what the transistor's doing. Let's look up where the 3904 is mentioned. I'm sorry? 0 results. This classic circuit uses a generic devices to assemble function little LT blah blah blah. Rail to rail input type op amp is required to sense voltages are right voltages are right at the upper, since input voltage is right at the upper rail. Sorry. I guess I probably will need rail-to-rail. I don't know if the TLS72 does rail-to-rail. The circuit shown here is capable of monitoring up to 44-volt applications. Beside the complication of extra parts, VOS performance of op-amps are supplied, generally not factory trimmed, thus less accurate other solutions. The finite current gain of the bipolar transistor, small source gain error. What does any of that mean? Okay, over the top current sense. What? Over the top. 3 volt to 44 volt. This is just 5. 200 ohms, 0.2. It's all the same. 200. So if I see. This has an extra transistor there into the negative. Circuit's variation with classical circuit, but takes advantage of the over-the-top input capability to separately supply the IC from a low voltage rail. This provides a measure of fault protection to downstream circuitry by virtue of limited output. Oh, so this won't blow up your other stuff. But I don't really need to worry about that. We know that we're 12 volts, and the screen is relatively well protected. If I do 0.5 here, and these are still 200s, I wonder if I'm going to get the same current reading as the 0.5 ohm shunt on the other end. Oh my God, there are the equations. Holy crap. For RA is equal to 1K, RB10, RS is 1 ohm. VO is equal to IL, RB over RA, RS. What the heck? VO is between those two, and then we would do a little V equals IR on that, huh? All right, well, let's get a TL074 out and a 3904, and let's just build this first circuit and see what we can do. Oh, I almost hurt my neck just by moving it normally. Oh, I gotta limber up more. Whoa. What is that? Damn. I feel like I almost popped something just by moving my neck. Welcome to your 40s. Okay, let's do this. Let's get a TL072. Where are they? Depending on the time, my op-amps might be in one or several places. I believe they're all the way over here. Potentiometers, I don't think we're going to mess with them yet. And the resistor values are fairly plain. Nope. There they are. If we do this, I'll need 2, so I guess it's going to be a TL072. Back over here. So, TL072, very generic part. I do have other, like, you know, non-plus minus 12 volt ones. Is the, do we need to go into... We actually don't need to go into the minuses. I could power this off of the 5 volt rail and use a different op amp. I don't know if it matters. All the circuits use these other op amps. What do I have? Do I have any normal components? I try to dig out a couple here. Actually, I gotta use the tweezers, otherwise I'm gonna bend all the leads. Mine's got solder on it. Weird. Yeah, let's take a look at some of these on the microscope. Microscope. That's not the microscope. There it is. MC34082P. 34082P. 2P. 8-bit, what? JFET? That wasn't a data sheet. It's a single? Oh, is it a double? JFET input operational amplifier. New generation of high-speed JFET monolithic operational amplifiers. Okay. What's our input? Is it this one, though? I don't know. This might be a singular... This might have been from the research project, the optical thing. VIO? What is it? Come on. Where are my specs here? Negative. Okay, so this is like a plus minus 15 volt. Jeez. Okay, we don't need this. That's a little bit much. That could work in the system, but yeah, these are left over from the drawers and cabinets of the brain monitoring probe research lab. Oh, this is definitely not going to be something normal. CA3140 easy. 3140 easy datasheet from Intersil. That's an I. Intersil. It's a link that nobody's clicked on in 30 years. Oh, there we go. Technical issues. Oh, okay. Well, just show me the datasheet, please. Renaissance, they must have bought. Integrated circuit operational amplifiers that combine the advantages of high voltage PMOS, high voltage bipolar, the CA, blah, 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 operational amplifier for the MOSFET PMOS transistors input circuit, I don't care. High input impedance, very low current at plus minus 15 volts. These are 15 volt products, most of this stuff. All right, let's just go to the TL074. That probably is also 15 to 18 volts, but I guess audio stuff way back in the day used 15 volts. Same thing. Next. These things are like in a fight. Oh, where'd it go? Yeah, those are all okay. So they're all about the same thing. They're like high precision, but they're I don't know. I might as well just use TL074s. Might as well use TL074s. There's going to be no difference between the two. It should be a TL072. Check. And I guess we'll power it off of plus minus 12, even though I don't know if that'll really accomplish anything. So TL072, that's easy enough. Let's get all the extras out of here. We're just going to test this with one and see if we can make a high side monitor from a low side monitor. We can monitor the current on this thing from one to the other. Maybe I can put a tuning resistor on it or something. And I got a lot of these things on the field today, these TL072s. So we're going to power this with, I guess, their own power supplies. Ah, there we go. Okay. That means we're getting minus 12 from here. And what is the pin out of these things? They're pretty standard. I should just memorize this. I haven't yet. Eventually, through osmosis, I will memorize it. But pin 8 is positive voltage. Okay. So if I go and I do positive V over here, we'll do input voltage from here. And then I guess I'll do long wires to get to the plus 12. Long wire. Online. So we'll go from plus 12 to pin 8. And then we do minus 12. That'll be a shorter one. A little short one to there. Okay, so now our op amp is powered. So our circuit is going to look at the following. I don't think I have a 1/2 ohm shunt resistor, but I do have 1 ohm resistors. So I could put two 1 ohm resistors in parallel. in order to create our shunt across the plus and minus leads. Now, R2 and R3, we're going to jump from the application note here. So let's get two 200 ohm resistors and two 1 ohm resistors and two 2 ohm resistors, and then one 3 ohm resistor and a 4 1 ohm resistor. Bonk. Okay, let's see here. So 200 ohms. We haven't used that lately. Although I did grab one the other day. I grabbed one yesterday, I think, in order to make our load resistor. We'll have to figure out what load we want to actually measure. Okay, let's see. 5M6. 1M. 10M. 2M, 330K. Okay, so we're on the other pile. 470R, that's more like it. 220. 10. Of course, 200 jumps to 180. We can't have nice things. I can't have 200 ohm resistors. What is the effect of those resistors? I mean, it is measuring between the two, the voltage levels between the two, and then we take that to the 2N3904 that's connected to feedback for some reason on the plus line. So if I make them 220s, is that going to be, because they should be matched. They should be very closely matched. Let's just see which of the 220s are very closely matched in value. Now I don't have the super multimeter sitting here, so I could go get it and we could do a very high precision match, but this is just a FAFO operation at the moment. We're in the F stage of FAFO. All right, I'm gonna need that to stabilize. Damn it. Do 20.3. 20.6. Nothing. Damn it. 219. No. 219.8. 219.5. That's close enough. 221.1 or 221.0. Huh. Let me get 200 ohm potentiometers and just make the match. 221.3. Did we see that one before? 219. It was 221.1. 221.0. Well, now this one's heated up with my body heat. 221.2. These two are actually very close to one another. It's all about statistical averages with this kind of stuff. There's a 1% swing in these, which makes them a little bit more expensive, but you know, sometimes you got to sit with the multimeter and measure them out, especially if we're building a precision piece of equipment. I wonder how much more the higher precision levels are. If I got like a % accuracy. Now the other resistor is 0.2, but the one in our system is 0.5. So I'm going to get 1K, two 1Ks, and just put them in parallel with each other. Parallel. Where are my 1Ks? Where are my 1Ks at? Here they are. God, this resistor thing is such a mess after we've been doing analog stuff. It's good to have a big collection of resistors when you're working with stuff like this, but it's been picked over, replaced, and all kinds of crazy crap happening to it. Okay, so these two are going to be the ones that are in parallel. And then the only other resistor that's required is a 2K. These are all measures of 2. I wonder if I made them measures of 1, if that would all make sense. Or 5. But it gets a 2K to ground. So let's see. I don't know if I have 2K. I guess I could do 2 1Ks to ground. God, it's so stupid. I'll do it. I'm gonna do it because I don't have a 2K ohm resistor. It's gonna be like 2.8 or 2.2 or one of those weird values. So we'll just do 2 of these in parallel. When it comes to surface mount resistors, I've got more variety. I'm gonna be using a lot of surface mount resistors in the design of this thing. Just because I hate through hole. I hate through hole with a passion. What a mess. Okay, so. We're gonna grab first amplifier. We'll use the one on the left here, and then I'm going to create this circuit. The input voltage is already dealt with, but from here to the load. So we have, I guess on the other one on 5 volts, we're gonna have to power it with 5 volts. The 5 volt regulator just kind of left. Well, I guess that's okay because we're using 12 volts right now. So we're powering it with the same power that we're measuring across, and we have a 200 ohm to plus. And these are like 220. So from positive to the plus line, okay? And then this thing goes, plus is pin 3. So basically from, that's V minus. So from here around to there. I'll get out my little circuit tool. That thing is kind of neat. It just kind of helps me plan these things out. A little bendy jig. So let's see. It's a little sloppy to do it that way, but I guess it'll be okay. Straight over here, and then down. And then cut it to length. These. I'll have to find my 3904s. Actually, is this? No, it's LM4040. There might be one around here, but I also have the through-hole ones. Okay, so from input to plus, right? From 5 volts to the plus, we have a 220. Okay, yeah, that's right. So then this one, down here. Let's go close to the chip. Actually, this thing could short it out, so I'm going to go from here. There, and then we go to pin 3, which is right here. That'll be straight down. All right, let me get this out of here so I can do the remainder of the bends. That was basically just marking it. Straight down, and then cut it to a similar length. Boy, that one really has to walk around the park, doesn't it? I don't know what the effect of using a plus-minus rail amp is going to be. All right, let me put this in here. Oops. That's one of them. One component is in. The next one is a 200 ohm from the other side of our shunt into the, so our shunt is going to be 2 of the 1Ks. So let me just make that real quick. All I'll do is just bend these per the size of the resistor. Just use this tool and just make them the size of the resistor. Because our shunt will just go down here. And then I can do another resistor that goes up to that. And then we'll do all the output stuff. It'll come together pretty well, I think. So, a little clippy. And now these have to go in parallel. So, we'll do one like that, and then one right next to it. Unless, it's going to be cleaner if I actually jump over to where these things will be in parallel. So let's put just a little yumper on that, and just move it to a separate part of the breadboard. Put a little jumper on that just to move it away. Now I can put 2 1Ks in parallel. Parallel. Ah, come on. Problem with these thin lead resistors is that the clips inside of these things are awful. These aren't that special. I wanted to try to find old school resistors with like big leads. You know, the ones you used to be able to get at like Radio Shack for like $5 for a pack of 4. These are more ubiquitous. You can buy for like $12, you can buy a whole kit of these things, right? These used to be very fancy. These used to be like, woo, somebody's really spending. But the problem with these is that they don't fight these clips inside of these cheap breadboards very much. Like, I'm having trouble with this one right here. That hole's just, it's like me, the hole's just ruined. They can't really do much against, like, you know, bad breadboard. It's like ruining the resistor right now. Oh, God, it pisses me off so much, because sometimes the little clips inside of these things, and you can see the little clips, right? Sometimes those are worn out, and so you don't get grip on these little tiny leads that come out of these things. And the reason for them is that the reason they're so ubiquitous is because they're cheap. You know, you don't need a lot of metal to make these things, and it's just ever so slightly cheaper than using the proper lead spacing. What do I have multiple? Okay, I think this is the 1K. I have another 220. Oh yeah, because that's going to the other side of the load resistor. I got it. I remember what I'm supposed to do. We might not get to testing this today. We'll see what we do with this. Maybe we'll do all the testing for it tomorrow. We'll just build it today. I should be faster about this stuff, to be honest, on stream, but it's we've had to do a lot of theory today, and that's not really my strong suit. But I think this will be a good solution if it goes together properly and does what we want it to do, and I can get it to tune. Why did it go into the wrong? Give me this back. I loathe these resistors. I loathe them. I hate them so much. I don't know where I can buy a set of the old school ones. You can actually call sales engineer. You bypass the glut of searching through data sheets for the lead thickness. That could be a good idea. No, I know, because then I would have to get permission from the person I call to broadcast. Now, yeah, that's a little. You don't want people who are unaware that they are on stream on your stream. I know IRL streaming is a thing, but that's in a public space. So when you call somebody, there are wiretapping laws that you have to worry about. And I don't want to deal with that. I would love a DigiKey sponsor. That would be pretty cool. And I I do absolutely take note that you can call them and be like, hey, I'm looking for a kit of resistors that are normal sized, that don't have these 1/8 of a watt freaking leads on them. Also, the other part that's really annoying is gripping these resistors like this. It's like the tweezers will throw them. They just throw them. There. Jeez, 2 1Ks in parallel. Sure is not what they will say. No, no. Hey, I do tech broadcasts. Can I call you really angrily and, yeah, no, I don't think so. Oh, I'll have to talk to my boss or something? I don't, what is it? Yeah, hi, this guy on the phone, he's got a weird question. I'm not sure. We might be a first party state. Where are we going? We are going to the negative lead from the other side. This is all topsy-turvy. All these, I want to move over to here maybe. From this side of the load resistor. So we're going that distance no matter what. You know, I've tried stuff like that where I talk to somebody about doing something like, hey, you want to like sponsor or advertise? And it never goes well for me. I don't have numbers. All right, let's get that one measured. So you can get it in right here without shorting anything out. That's actually going to be a little difficult. And if I go closer to the chip, I'm still also threatening to short stuff out. Well, this is crooked enough that it actually does work. Cool. Okay, so there's that one. So that's both sides with the 220K going from power input and going from the other side of the shunt resistor. And we've got 2 1Ks. Wait, 2 1Ks in parallel. What am I thinking? Yeah. I need a much smaller resistor. Those would have exploded. Two-party consent state. Oh, yeah. There you go. We like our consent here. Let's go all the way down to the lowest resistor value that I have. $75, $8, $5, $4, $2R2, R2, R2. 1. So use 2 1s. Two singular ohm resistors working together to create half a working resistor. I feel like that's what meetings are. You know, everybody thinks that if everybody gets together, we're going to be smarter, but we're like resistors. Our value is going to have per person. Our value will be a function of how many of us that are here. All right, get this down to the size of the resistor. Bend the leads. Chop the leads. This is just so we don't have resistors sticking out of the board. I like myself a nice neat breadboard. A nice clean breadboard setup. Because when it comes to troubleshooting, you don't want nothing getting in your way. Why do you have so many? Yeah, because the kit comes with that many. And resistors are one of those items that are super cheap and they're basically valueless. Even though I could reuse them between designs, I just end up throwing a bunch away. That's just how it works. Economy of scale. That's a big thing in electronics. That thing is still giving me grief. Go in there. Why do you hate me? Oh my god. This one right here is on my shit list. This one right here. There's something wrong with the hole. Why do you have silver band? I guess that's just the... Index C for 40 months. Index C, thank you so much. 40 months of subs. That's impressive. I promise you, we will get your name on a board. There we go. Damn, that was so annoying. Okay, so those are two 1 ohm resistors in parallel, and then our load goes between here and ground. That is the load that we are observing on the positive end of 12 volts. Ah, wait a minute. Positive supply rail current sense. That's what that's supposed to be. But is the 5 volt coming in from there, or... No, we are supplying 12 volts from the top of the load. Okay. How much current do we want to have going through this thing? Well, we want to have, let's say, 500 milliamps. So if we want 500 milliamps, that's half an amp. So we need a resistor of what? It's V equals IR. And so we want 0.5 R equal to 12. So we want 6 ohms. Is that right? 12 over a half. So it's 12 over 0.5. So it's 24 ohms. If we do 3 by 7 ohm, we'll be going a little bit over, it'll be like 400 or 300 milliamps. So let's do 3 of the 7 ohm resistor. I've got that set up over here where I've got the ability to hook up to 3 of them. Actually, I don't have the ability to hook up to 3 of them. Wait a minute. That's funny. It's 4 or nothing. 4 or nothing. Well, 14 is 28, right? So it's not, I did my math wrong. 7 7's 14, so 28 ohms. So that would be 28 over 12 over 28. Is that right? I don't know. Math is hard. Anyway, whatever. I think if I just use the 2 ends of this thing, that'll give us our load. So I'll go from here into our 12 volt supply, which I'll just grab over here. There's a load resistor. All that remains is for the 3904. Oh, and a 2K to ground. 2K to ground on the output of the op amp. I've never seen someone do a circuit drawing in paint. Oh, here we are. I don't know what to say. Spent my whole life training for this. Out minus plus, or is it plus minus out? Output is the very top. Minus should be where that other 220 went. It is. Okay, so out minus plus. Plus goes to that feedback resistor. Plus also goes... well, the shunt resistor also needs to go to power. Wait, but that one's going to ground. Hold on a second. I'm confused. I'm so confused. Let's take a look at the... Let's stick to this one. Yeah, that's power input. That ain't power input. This here needs to go here. Why did I do that? Why did I do that? Working against my own intuition. so the... Oh, it's supposed to be here. Okay, so I need to find a longer jumper. That's what it is. It's a jumper issue. The yumper. My yumper. Get out of the way, red wire. Hold on, I'm gonna move this thing because it's really getting annoying. Oh my god, there's just stuff everywhere today. It's very, very obnoxious. Okay, so, let's see. From the 220 ohm resistor to one end, and then there's a 220 ohm resistor to the other end, and I just put that there to extend it so that we could get the two parallel resistor out of the way. Where are you, Yumper? You're gonna catch a cold. What's up, henchman? Sir, okay, I got a bunch of resistors sitting around here that I'm gonna have to test. I don't know what they are. So we have 220, 220. Those are going from the plus and the minus to other elements in the circuit. The one that goes to 5 volts, or whatever our input voltage is over. Okay. My brain is like leaking out right now. One goes there. Oh, this is wrong. One goes there, and the shunt. Wait a minute. There. I'm building that. I'm building that because that should supposedly give us a current mirror. We haven't gotten to the 3904 yet, but plus and the 3904 and the 220 share a thing. Plus does not go to the shunt. So get out of my way. This is wrong. Let's see. 220 goes to 5 volts from plus. But that's also the same as the shunt. So this should go to here or all the way back to where our power's coming from. So this will be another jump for power. So I guess if we overload this thing, this will heat up and look all pretty. That one decided to fight me too. That's too short. Longer jumpers I require. This one's too long, but I think that's the only choice I have. Oh boy, we gotta work on Will's barking. She's barking a lot lately. And it's getting kind of annoying. I know she's just a puppy. She likes to bark, and that's fine, but there are quiet times where she needs to be quiet. She barks from sun up to sundown. She's not as bad as other dogs. Other dogs bark all day, every day. So, you know, I'm happy that she's not like that. For sure. Okay, so this lead also goes to a transistor that goes to this lead as it goes to this lead as well. So it's okay, what's the configuration here? We got to go between plus and the lead that goes to the 220 ohm with a transistor. And the leads are organized like this, minus plus, yeah. And then 3904 pin out, and let's get a 3904 transistor. These are all so, you have to have a 3D picture of the transistor in order to get it right. There's so many old school transistor data sheets that are just so confusing. And you know, you're gonna always get that fucking jackass engineer that's gonna lord it over you. Oh, I just get it right. Like, go fuck yourself. Tired of dealing with people like that. Alright, let's see here. Transistors. I know I have a bin full of them. And a through hole. To boot! Is this one? No. I'm deep in the bins here. He's in his bins again. He's gone too deep. Too greedily. I found my ultraviolet LEDs. Don't need those. Alright, so where did that kit of transistors go? It's in here. I know it is. We'll find it. Those aren't. No, those aren't. Connectors, connectors, connectors. Did it make it out somewhere? It might be sitting out somewhere. All right, quick sweep. Where'd the bins go? Kits and kits of things and bins. Bins of things and kits. What's this over here? Nope, nothing. Aha, wait, no. Oh, but I think I have 3904s in this thing. This sort of excess through-hole stuff bin. There's a lot of crap in here, though. Is that a voltage regulator? That's a big one. Huh, okay. So, in search of the fabled 3904. Some of them might be on breakout boards. What are you? I think I used 3904s in the diode ladder. 3906. Wait, which one does it call for specifically? I think it's 4. That's a 4. I think in the other circuits they use 6s. The ones where it was 2 facing each other. That's not the view that I wanted. What is this view? Where are you guys? Where are we now? Oh, there we are. Okay. Where there's a 3904, there's bound to be a 3906. So let's just continue on and see what we can find. 3906. We're looking for a 4. Six. These are part of the parts that chat bought me because I didn't have all the jelly bean through-hole stuff back in the day. I was lacking in quite a few areas. Because I didn't really know what the jelly bean parts were. Now you just look them up. I think this is it. This is it. Make no mistake. 3904. There we go. Cool. All right. This has ended up becoming a dump for all of the components that I didn't need. You know, like when you rip stuff out of a breadboard setup, it's like, where do they go? Well, put them in a bin, think about them later. Later never comes. So the collector on this goes to the positive lead of the positive inverting input of the, so collector is pin, this one all the way on the end. So that one goes to plus. It's output minus plus. And then the, oh God, how's this gonna work? Collector there, then the emitter goes to 2K to ground. And the base goes to the output of the amp. So it would be better, oh geez, I really want to move that resistor now. If I go over here, I guess I could do it. So like this, and then this. All right, now we double check. Because then that goes to 2K to ground. So if we look, base is in the middle, the emitter is on the left. Well, on the right, if we're looking at it the way that we are here, the emitter's all the way at the top. Which is correct. Okay, cool. So that part of the circuit is now hooked up. So now we need 2K, and so I got to find the two 1Ks that I put aside. And I put them aside so long ago that everything has gotten messed up. So let me put these two, I think these are the ones with bent leads. Sure, that looks like 2K. The Roy G. Biv color scheme is not great for these things. I really dislike how hard it is to figure out. Oh, I guess these should have been in a different, these should have been done so that they could be more compact. All right, I'm getting 2 more 1Ks. I'm going to redo them. I have tons of 1Ks, so it's not that big of a deal. Here are the 1Ks. Just grab 2 of them. It's so much easier to do the resistors where they fit very compactly on the breadboard. The only problem with that is that when you build your circuit and you move it around, it's very easy to knock them and sort of mess up your breadboarding. It does help you poke the components when they don't work, but to do the really compact resistor, all you do is just bend the lead around like that. And now I can cut the 2 leads to length, and this is going to be a stand-up resistor that takes up less room on the board. Although, to be fair, this takes up exactly as much room as putting a female header on the board and soldering a resistor between the 2 leads. And I have far more surface mount stuff than I do through hole, so I don't know. Maybe I should have done that. So here is 1K in your eye. Come on. 1K right here. Oh my God, this fucking breadboard has been through. It really is the size of the leads though, because I can't put any pressure behind them. And you can see the little grabby things are just not letting it. There we go. Boom, there's one. And then the second one, bend around like that. Give it a clip. Bonk. And that one goes here. And then this goes to ground. We don't really have ground here. Does it go to minus? No, it goes to ground. And ground is way over here. So I guess what I can do is do just a long lead, longer than this. I hope this resistor doesn't heat up. What is longer than yellow? Not much, actually, on this thing. It's orange or red. Maybe red will get us there. These are distanced by color, so. Yep. Bonk. And yeah, that'll get us right over to ground. Okay. So the voltage measured at this junction here is going to correspond to the amount of current. And I suppose what that means is that we will put that voltage across our shunt resistor, and then that will be measured. The voltage drop across the shunt resistor will be measured, but that would be half an ohm to ground. I guess that's how it's supposed to work. I'm not sure about that. Like turning that back into or do I use a higher value? What is that? Measuring bias current to an avalanche photodiode. What the heck? Oh, danger, high voltage. 500 volts, oh my God. Bidirectional battery current monitor. Supply current included as load in measurement. What? Wait, what? Huh? R out, V out, R out, 499 volt. Laser monitor. Man, these are some cool circuits. It's like our sense and load. Do I need to put the load across? And then our load is, what was the value that we decided? Oh, yeah, it was all the 7 ohm ones. So our load goes from, oh no, but our load goes, yeah, on the other side of this thing. We've already got our load in the circuit. Sounds dirty when I say it, all that stuff. From minus to ground, where there should be power. So from here to ground. So this would be our load here, our 500 milliamp load or less, goes from here to ground. like that. So there's the load plugged in. Now we need to get the meter in the fray. So the meter, let's just use any of the meters. Meter here. Well, let's put the load here. Actually, we're over here with our load. I hate that I have to keep saying that. So, in that direction, is that correct? I guess. And then we're monitoring. We're getting our voltage from, not the 5 volts this time. We'll get it from 12. So these two will just be connected together. Here, let's just move all the wires over here. It's just easier to hook these up using big jumpers. So those there, these here. And then we do the little jumper for positives. And I guess, are we sharing the negatives? I guess we are. Oh, MS Paint drawing. I don't know, have you ever done napkin calculations? Like, MS Paint is not that big of a departure from that. It's just napkin calculations. Like, I don't know what people are using as tools for taking notes these days, but you know, we did it all on paper, and so it translates very readily into just jotting down notes like this. And this is actually much cleaner than my handwriting. It cleans it up quite excellently so that you guys can see it on your computers or wherever else you're watching. I mean, my understanding is that what we will have instead of, because what they have a resistor here. This is a slightly different. Is it a slightly different layout? Let me just take a look real quick. This is a slightly different layout than what we were doing, but only slightly. We have this one, and the two resistors. Yeah, we don't have a resistor to ground necessarily on the amplifier. They're looking for voltage difference between the two, but then we have a resistor to ground on the other side of the transistor, on the other side of the 3904, going to ground. Yeah, my handwriting is bad. It's worse than this. It's 0 to 4 volts. I don't know. I think we're okay. It's just that I already have a resistor going to ground here, but we'll do the black wire to ground and then our, okay, so we'll try this. Hopefully it works. If nothing happens, I'm gonna have egg on my face, I guess. Although not really egg on my face. I didn't like guarantee that this would work. I'm just. So this one to ground. And then black wire to black wire. Shorter. Shorter than that. Like one longer than a green. I don't know if I have that. I don't know if that exists. It is simply impossible. Orange, maybe? An actual application for the orange wire? My God. Way too low. No. Non-planar circuit analysis. What even is that? I've never heard of that. I have never heard of that. And then I guess this goes to the resistor over here. So that's actually a big jump. We'll use a green wire for that one. Okay, it's not like plugging in. Sometimes it fights you, and that's when things get really frustrating. 2K to ground, but then this is in the junction of all of those. So that really goes there, and that's gonna get shorted out by the wire that's right there. This is the top of this is the voltage output. And it's like right in the path of this resistor. It's the big mistake that I made was using this. I could jump it one further forward, but I think if I just go there, this will be a little bit better. So, okay, so that is the red wire. The red wire goes to the voltage output, and we're measuring that voltage across our shunt resistor. Is that correct? Is that what we should be doing? I think so. I think that's correct. Because the load would then be the 2K resistor. No, the load would not be the 2K resistor. The load would be still across the 2K resistor. What's going on? We have a voltage output. We have to turn it back into a current output. I hate these AI answers. They never know what I'm talking about. Putting it across the load. That's essentially what we're doing. Our load is a 2K ohm resistor, which would mean that I need to measure that current. So actually, I think it needs to go in the path of the 2K. So instead of, it would be like having a 2K like this. And then we would be measuring the low side of the 2K. Let's do that. Okay, so that would mean that we break here. And we measure here. And then this leads to ground. Okay, so I think we've set up our circuit. I'm ready to put 15 volts into this stupid thing and see what blows up. Now, presumably, we are going to get something like 300 milliamps as our current reading, and the board's going to heat up. There's going to be a little bit of drama around the board. Our load resistor probably won't heat up that much. So, minus and plus, and we are creating from that minus and plus, we were creating negative 12 and positive 12 volts. And then I ran out of insulin, and this thing started screaming at me. All right, well, we'll test it, and then I need to go do insulin, so I'll end the stream. But let me turn off this pod, because it's screaming at me right now. This is the Omnipod. I've just run out of insulin. Dash, no units. And so this thing feels the need to make a constant tone until it runs out of batteries, which, boy, that's great. Really good for my stress levels. Detach pod. Please deactivate this. Please die. Thank you. Jeez, hurts my ears. All right, so let's get this tested. So power off and turn on the power supply. We're at negative 12. I'm going to take that up to 15. Oh, wait, no, we're not. I'm not adjusting the negatives. I'm looking at the positives. Whoa. No, not 22 volts. One digit over, please. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 volts. Bada bing. Okay, 15 volts. Little man, put that shit in my hand. All right, so what's going to explode? You ready? 3, 2, 1, go. Well, shit. What ain't work? Oh, I didn't put positive voltage into the... Yeah, I didn't put 12 volts into the monitor. So that thing gets 12 volts. We're getting 12 volts from all the way over here. So I'm going to grab... Where's 12 volts going? It's also going there. So I can get it from right here. So let's find a jumper. That's one of the components that I forgot. One of the few things that I forgot. This one. That's not right. It should be longer than that. by just a little bit. I don't have one out. Okay, so I'll grab one here. See if yeller. Longer than the yeller. Which is that awkward length that isn't included in these kits. These things jump distances, and there's this awkward length that you just can't do on your breadboard if you buy kits like this. I buy kits like this because they're cheap and they explode. All the wires become all screwed up in these kits, so I buy the cheap ones, and you end up with this sort of discombobulation of distances. So this wire is going to be way too long, but whatever. Whatever. So from there, we go into positive. So now our meter has power. That has positive 12 volts on it. Now, in the future, I'll probably power them with 5 volts. They don't need all that much voltage. I'll power them off of the 5-volt regulator, but since we've only got the 12s on the field right now, we'll power it with that. And then tomorrow we can take a look at whether or not we can get the full system up and running. Okay, so 15 volts into this thing. Hopefully no fires. Yeah, Anonymous gave out some gifts, and I don't know who that is. Nothing? I'm not even drawing current, actually, so that's a little concerning. Well, our 12-volt supply isn't hooked up to anything. It's not hooked up to power. I wasn't thinking straight. So, ground, V plus, that's fine. This one is hooked up to 2 grounds. So we need to get a slightly longer pin on that. Pop this sucker off. It's about to pop off. There we go. So those are all hooked up to power. Nothing else is really going on over here except using the ground. That ground over to there. And this ground, well, that's V minus. This one goes to V plus on the out pin. And then that V plus also goes there, and then it also goes down, and it powers our little board on these pins, and then this pin goes over to ground. Ground is also on the lead of the shunt resistor. The other side goes to the shunt resistor, which is a 2K, which is two 1Ks in parallel. And then we have that on the emitter. Okay, all that stuff is all configured. That goes negative 12 there, nothing else to negative 12. And then our actual shunt resistor on the positive power over here. Red lead goes to our giant shunt resistor that goes to ground over here. And so that should be 12 volts as given from here through the shunt to there. I think everything's hooked up properly. And our shunt should be half an ohm because it's two 1 ohm resistors in parallel. Parallel. Son of a bitch. Why? Oh, I didn't hook it up. Okay. Wait a minute. Don't yell at it yet. Okay. 3, 2, 1, power, go. Son of a bitch. Is anybody exploding? Almost this guy. Why are you almost explode? Negative 12 does not like what we've done to it. Okay. What are we even talking about? Why are you get hot? Why are you get hot? We give you plus voltage. We give you minus voltage. You have both voltage. You have both voltage. And then V minus goes out. Those two grounds are just a big ground plane, so this should be functioning perfectly fine. What about you, Pololulu? You get ground. You get input. You get no enable. But enable actually has an internal resistor on it. We know that about these. And you go out. And then you go out over to here. And out goes to resistor. That goes there and does all the current following stuff. Why does my power supply not turn on? Going low blood sugar because of hanging out with us. No, 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 that would be hyperglycemia due to the stress of talking to you assholes. And then the pump uses more insulin and then it runs out of insulin. Why do you not light up for me? Ground is ground, power is power. This is 15 volts. I hook it up. Everybody should function. Nobody functions. Also, I blew up this this driver. Hold on, let's check the one next to it. We might have blown that one up yesterday with all the shenanigans. Oh god, the last thing that I want to do is order more of these things, if that's the case. Nope, still not a whole lot of nothing. And that guy's getting hot pretty fast. Why would this get so hot? It gets all the voltages that it wants. It should be producing the right voltages. V minus. I must think on this, chat. Let's check the third one and see if that one does anything. Well, actually, we could just test it by giving it power. Power lead ran away. Yeah, so it does actually work. This doesn't sense anything. Now let's just double check. Minus, then plus. Oh, there we go. 0 amps, though. Is anything else exploding? Our shunt is actually getting warm. Not that warm, but it is getting... Why are these two? Was that touching something it shouldn't have? Maybe that's what it was. Is our transistor heating up? No, that looks okay. That's not it. That's it. That would be our... That's our load resistor. Or that's the resistor across our main load. Yeah. But then... So that one should get hot with all the current that we're pushing through this thing. This thing says we're running 382 milliamps. This does not. That should be 0.38. And it shows nothing. So our scheme of measuring across that 2K is not necessarily doing what it should. Because we're not connected to ground. No, we are connected to ground. We're going down here. We're going downtown. So, what are doing here? What are doing? Nothing are doing. Our transistor isn't heating up, is it? No. Yeah, a little bit. It wouldn't be backwards, because you go, according to these things, you would go from black wire would be on the side of ground. Yeah, because I think that's how everybody else. Oh, but wait, yeah, red out to the load and then black back to ground. Yeah, red wire goes to where the load is, black wire goes back to the... That's not even relevant to us anymore. Man, the shared grounds on all this stuff really screwed us over, didn't it? We had no possible chance to isolate things out. I'm not going to use transformers, that's silly. So, I mean, we got the screen to light up. Whoa! The only thing that's left is shunting our current. We need this to parallel the current that's being utilized on the input. at, it doesn't matter what voltage it's doing it at. All right, I'm gonna have to think on this a little bit. It might be different value resistors or something. You know, going across a 2K resistor might not be what we want at all. What if I just short out the 2K resistor? What's that gonna do? I don't think that's gonna do it. I don't think that's a good idea. Just goes through the 2K. But what if I bypass that and look at right here? Nothing. All right, so that doesn't matter. Nothing. Nothing changed. No, 1K. Nope, doesn't matter. What if we measure the voltage real quick at the where the voltage is supposed to change based on the load? So the voltage here would go to here. 10 volts. 10 volts. And then what if that load was dynamic and something happened to it? 9 volts. Oh, but then it doesn't change? Damn it. It didn't do anything. It didn't do anything. No, it's not changing. 9.6 volts, huh? All right, so we need to adjust stuff. Maybe try the other circuit. See what that'll do. Because, yeah. All right, well, it was partial, not really success. It didn't really work. Maybe we can put it on the scope tomorrow and I can do a little bit more dynamic measurement to that. I don't have like a variable load at the moment. So we got to figure out, you know, this whole voltage mirror thing, current mirror. I've never heard of it. I've probably done like coursework with it, a current mirror circuit, but I've never heard of it before. I think it's the right answer. It's just the question of like implementation of the answer. We got close. We built the circuit. It's still a little bit confusing, but I need to figure out how to get this thing to see the current from the voltage that this thing is creating, and I think it might be down to like tuning stuff a little bit just to create the right things. I hope I don't have to use the other op amp on this thing, because if I have to build something like this in order to give us the like a current, and that says 4 to 20 milliamps, and we want this thing to presumably measure up to an amp of current. So that's a lot of power that needs to come out of something, I guess. I don't know how that works. I thought it would be measurable across something else, but I don't know if that's really the case. It might be down to measuring milliamps with these things. I don't know. It's a weird scheme that we're coming up with. It could also be that maybe we need to bypass the shunt like entirely. I just want to use these little screens to measure current. It shouldn't be this hard. It's never easy. It's never easy with this stuff. So we're going to think about this a little bit. I'm going to hopefully come up with some ideas. Hey, Fatanon, the tier 3 sub. The current is stored in the balls. We've been looking in the wrong place. A revelation. A late game revelation. No. Thank you for the tier 3, Fatanon. I really appreciate all the help around here and all the subs. I don't know what this thing is. I've got like a little thing on the bottom of my, you know, this is like where I plant my wrist on stuff. I've had this little like calcification or something like that, and I always pick at it, but it always comes back. Like I could use the flesh cutters and get this, use them as flesh cutters, and get this as flat as possible and try to remove whatever this little dot is. I've looked at it under the microscope and it doesn't look like anything, but there's always just a little pinpoint, like a little something under my wrists like that. I wonder if it's like a wart. A mere flesh wound. It's the flesh cutters, aka flesh cutters. There we go. I cut it flush. You know, it's not like I can feel anything on it, but now that's nice and smooth for just a little bit, and then it'll go back to being a bump. It must be like a micro wart. I don't even know. Anyway, anyway, that's the note I'm ending on. You guys all go touch grass, and I will do similar. I'm gonna go take the puppy for a walk, and we'll think about what we've done today, because we have to figure out how to measure the current on the high side of this circuit. Our equipment doesn't let us do that. If that's going to be reconfiguring something inside of these drivers to get that current, or if it's going to be building our own circuit. Because what they're doing is they're dropping that voltage differential through a couple resistors right into the microcontroller. It's possible that we could come in here and alter this a little bit and get it to do our bidding. We'll think about that. It's a very simple circuit. So if we add an op amp, if we add a voltage, if we add our scheme here to this, I can make a little board that'll just go in the back of this thing, and then it'll measure high side current instead of low side current, and it'll give the current to the micro that'll then produce the number on the front. That may be the way to go. Maybe that's what we do. I convert this thing by going directly into their microcontroller instead of trying to create like an amp of current through something. We can just use the op amp thing, tune it properly, and then get that to talk to the micro. That's what we'll try tomorrow. I'll see you guys then. Have a good one. Go touch grass. Panic, I forgot the end card. There's the end card. Oh no, but this thing didn't refresh. Okay, hold on. Let's properties, and then I hit. I've been having trouble with these overlays, these web page based overlays. Refresh cache. And then I can do the end card again. None of the stuff has been updated on it anyway. Okay, it's not showing up. What the okay, anyway, I'll catch you guys later. Everything's breaking around here.